welcome you all on second technical session of Automatus 2020. This session is based on new applications of automation. Automation in various areas like medical, automation in agriculture, automation in infrastructure, industrial IoT, and automation in pharma. For this, we have Mr. Rishikesh Bhagat with his vast experience in process instrumentation and process automation. He has done his B from Bharati Vidyapit College of Engineering. He has also done MBA from Jamnalal Bajaj Institute of Management and Studies. Currently, he is working with Honeywell Automation India Private Limited as Strategic Manager in Sensing and IoT area. He has also worked with Hauser, Omron Automation, Mitsubishi Electric. He is member of ISE Maharashtra section. He has more than 11 years of industrial experience. On behalf of organizing team of Automatus 2020 and VCET, I welcome Sir and request him to begin with the session. Thank you.
Is something new which I'd like to introduce, not like a typical session what we introduce every time. This time, I want to focus on new application in automation. So basically, automation is a huge field, and we have n number of application in automation. But in today's world, especially after the pandemic of COVID, there are big challenges against us in every field, from finance to projects, from engineering. And in this case, how can we identify new application and rebuild our economy with our career? So last week only I came to know that there will be my few audience will be my student. So I improvised my PPT from student point of view and also professional point of view. In today's PPT, I will be more focusing on the applications which are upcoming or which are a new trend. So let's start for the first one. So the contents will be clear, like automation in medical, automation in agriculture, automation in infrastructure, and automation in IIoT, and automation in farm. Now, if you see, all these 5 topics are the concerned topic or the recent trends in our industry. Now, talking about medical, after pandemic, before pandemic also, the medical field was quite sensitive, and it has become more sensitive and a cash cow after this pandemic. Agriculture also responded the backbone of Indian economy, still backbone of Indian economy, which is more focusing and funding is coming from the government. Third is the infrastructure, which we are talking about the automation in infrastructure, automation in IIoT, which is the boom industry nowadays. And last but not least, automation in pharma, where we are dependent on pharma in this pandemic for a vaccine to come. So if you see all this five field of in which automation is the recent trend and will be boom after pandemic also. So even after the students who are planning to make that career after completing that diploma or BE in instrumentation or any other field, after this PPT, they may think on which field they can make their career depending upon this slide. So moving that a basic need, why automation is needed. So recollecting the dialogue of Mr. Amir Khan of Kunsuk Wangdo, that automation reduces the effort just from your mixer, your fridge, everything is based on the automation, maybe a closed loop or open loop. But automation is the need. Without automation, we cannot think. So everything in this world is based on the automation. So what are types of automation we are? So basically, when we come in automation, automation is basically divided into three. First is the industrial, which we are dealing with all the industry like pharma, F&B, everything, industries, factories, industrial railways, transportation, metros, all this comes under industrial automation. The second one is the building automation. People also call this as the office automation. So when the office automation come like automatic door, infrared base, your CCTV cameras, etc., comes under the building automation or home automation also. Scientific automation, we call as the rocket launching, the ISRO, which and NASA comes under the scientific automation, where automation is the main play key in that. From rocket launching, from designing of the rocket, from launching of the rocket and tracking the rocket or the missile or the satellite in the space is done completely on the automation base. So just you can imagine from grinding a mixer to handling your satellite in the space, automation plays a major role in our life. So first we'll talk about what is the automation scope in medical. Looking at the picture, I purposely kept this picture on my PPT because this is the picture of the ventilators, which are a very high demand in the world nowadays. You can see that the medical, if you go in Chicago, in USA, a city like Chicago, which is known as the epicenter for the medical devices. People completing their BE in biomedical, they plan to go in Europe or in USA, Chicago, epicenter for medical. So what scope or what automation medical is doing? Now, if you see that after this pandemic, when it break out all over the world, all countries' government has decided a huge or mass manufacturing of ventilators. And in India, if you see, the automobile company was invited to manufacture the ventilator. Why it was so? There are many OEMs of OEM means the original equipment manufacturers of ventilators like ResMed, Medtronic, Philips, etc., who Agua Healthcare, who are the masters, or we can say who are the pioneers in manufacturing the ventilators. But still, Indian government approached the automobile company. The first thing the approach was due to they having the ready-made infrastructure, the machineries. So the base machine, when the body of the ventilator, you need CNC machine. So a normal automation maker can't develop or can't procure CNC machine as early as possible. So it was the group like Tata, Maruti, HM Motors, and Mahindra & Mahindra who took the lead of developing and manufacturing the ventilator. I'm mentioning the word developing because this manufacture, the challenge was to develop a design in a very short period of time. So in this, they had a tie-up with the big OEMs like ResMed or Medtronic. They have a technology transfer on the design, and they started the manufacturing in a very short period of time. So if you'll ask me, so what is the automation in medical? We never thought that in the medical devices like ventilators or any other, what automation it can feel. In India, we have all over the world, biomedical engineering is a separate field. But in India, especially in Mumbai University, you'll find hardly few colleges And that is the biggest problem, that our country is not focusing on the basic need of the education, the basic need of the infrastructure, where medical plays a bigger role. So let's have a look. What is the automation in medical? So I will talk about the ventilator. Now, if you see, the medical industry is the least or zero affected in any recession. It may be a recession of 2008. It may be a recession currently which is going to coronavirus. The medical industry will never going to affect in future also, because medical is the base, is the essential to the human life. Now, talking about ventilators. Now, why the ventilators demand went high? Okay, now being a technical person, you have to think a little bit of commercially or economically also. It was a world or day where the engineer used to take a screwdriver or repair with the multimeter. The days have gone. You have to think and club jointly how it work techno-commercially. So when this demand hype up, because due to this virus, it was a chances that people, the oxygen level in your lungs goes down due to the virus attack, and you need the ventilator. It was the basic thing, and this is the basic principle how the ventilators work. Now, the ventilator is to blow the pressure into the lungs, which is known as a positive pressure, and the negative pressure, what you call about when you pump, you takes out the carbon dioxide away from your lung, it's called a negative pressure. Now, patient usually exhales the air on its own, but the ventilator is a mechanical device which is used to pump the amount of oxygen based on the condition of the patient, and it is monitored. Now, when it is monitored, means what actually? The word monitor connects us with the automation. Now, though it is called a mechanical ventilator, but this complete ventilator having a microcontroller or PLC, HMI, programmable, and there are two products which plays a major role, and without that, the ventilator won't survive or won't work. That is the sensor. Now, which kind of sensor it is used? So I'm going to come that how the sensors work, what is the standard rate of the standard is working, and how these sensors are modified and they are shortlisted, and what are the brands or who are the makes in this. So now going further, when as you know that ventilators are required and we require air and oxygen in this. So basically the sensors which plays role are the oxygen sensors, the airflow sensors, and the pressure sensor. Now you will see oxygen is essential. So when oxygen comes from the cylinder, it blows into the lung, it has to be go in a proper amount based on the patient condition as well as the air. Secondly, the pressure has to be controlled. If the pressure and the flow is not controlled, definitely the patient will die because of the excessive blowing of the air before he will die about coronavirus. So there are many cases which come in front on the news also that it was due to the ventilator failure. In long back, I remember 1 year ago, due to the oxygen cylinders were not available, the ventilators were not working, few kids would die. So this is what the ventilator is all about. If it is not calibrated from time to time and it is not properly working, this failure may lead to the death. So it is very important that a ventilator should have a proper sensor in this. And the three main sensors, I'm repeating, it's oxygen sensors, it's the airflow sensors, it's the pressure sensors, which plays an important role. So sizing of the sensors are very important. So this is all what ventilators is about, and everybody is aware about ventilators. Now, the typical types of ventilators are like portable ventilators and the stationary ventilators. There are ventilators which are used in ICU, but there are little different because ventilators, basically, it's dependent upon the working mode. So let's go forward with and try to understand what the ventilator modes and the flow rates are. Now, when you say me a typical flow range of 7 to 10 SLPM, standard liter per minute, okay, and the typical pressure range is of 0 to 20 centimeters of H2O. Now, this is the unit cm H2O. It typically used in medical application or medical devices. So if the ventilators manufacturer, when they come to us for selection of a sensor, so we are aware that what first question what we ask when a ventilator manufacturer asks, okay, I am manufacturing a ventilator, so I need a sensor. We ask the first question as an engineer point of view. We ask, what is kind of sensor you are manufacturing? We need to know the flow rate. So when it comes to airflow sensor, the standard rate is around, for airflow, is typically around 0 to 200 SLPM. It varies 100 SLPM. But when a pressure range comes, we are again asking whether the pressure is going into -1. Many times, the pressure range is different from ventilator manufacturer. So typically, one of my customer who is taking -1 to 1 pressure range. Okay, so it comes to -1 psi, which is the typical pressure range he believes. The other customers have the pressure range of different range. So it is depend upon the flow range, and the pressure range. And it depends completely on the design and where they are going to use. So when this typical ventilators I'm talking about for the adult ventilators, more than 12 years or above, adult ventilators. So typically when the customer asks me that I want airflow sensors, the pressure sensors, and the oxygen sensor. Now all these sensors are depends upon the flow rate for the airflow and the pressure range for both. So this typically when the customer design it, they require all three sensors. So any ventilator manufacturer, without the sensor, he can't manufacture the sensor. Now, again, coming in the airflow sensor, in airflow sensor, if you see, there are two types of sensors. First is the disposable type, and second is the stationary type. Now, if you ask me what is the disposable type and the stationary type, the word stationary means that the airflow sensor, okay, will typically be mounted in my design of the ventilator where the air comes from the cylinder. But the disposable type is like the disposable type goes almost near the nose or mouth of the patient, and after it is used for one patient, it is disposed immediately. It can't be used. So these are the difference between the two sensors. So any ventilator, if you see in future, if you visit any manufacturing of a ventilator or in hospital, you will see if you find some sensors near the mouth or the nose of a patient, there are typically a disposable type airflow sensors. And if you find a normal tubes along with the sensors are inside the ventilator. So this is something, the difference between the airflow disposable type and the stationary type airflow sensor. Now the pressure sensor. The pressure sensors arranging are typically kept into the ventilator's design, and this it is basically designed or interface with the microcontroller. Now will be many microcontrollers available from the Arduino or 8086 microcontrollers, but few manufacturers also believe using the ventilators by using PLC. So the typical PLC what they is around DI of 12 and DO of 8, which I use. One of my manufacturer, like name as Krishna Engineer, who is the consultant and the technology transfer. I'm going to show the video also after this, before my session end, that how you design, how you size the sensor, and how it is used by bellow. So normally when the lungs are like when you inhale and exhale, it expands and contracts. So it is just like a bellow. So when you blow the air, when the air goes to the sensor, it has to be set from the microcontroller, and my flow range depends that how much air should be blown. As I mentioned earlier, if the air goes beyond the standard or below the standard, the patient life will be at risk, at high risk. So you have to be very, very concerned. So normally a typical respiratory rate, if you see, is around 20. Very high, you see, it will be difficult to breathe. So in this coronavirus also, when the lungs are full of the virus or the carbon dioxide, the breathing will be problem come, and the breathing will be really less, like less than 10. this was a concern. So typically respiratory rate is set in the hospital, and all the doctors monitors this. This is a standard set in the ventilator, and this is monitored. So as you see that the most commonly modes they have been given below. The assist control mode is also known as volume control. This is the mode where the ventilators normally on 90-95% cases, this ventilators work on this mode only. And the second mode is the synchronized mode or intermittent mandatory ventilation, SIMV mode, which are very less used for the very, very critical patient, the pressure control mode, and the pressure support ventilator mode. I'm not that much expert from medical side to explain you depth about mode, but these are the when customer asks me that there are 4 modes available in my ventilator, but typically my sensors should work 100% in the assist control mode. So this is what the ventilator is all about. I have, yeah. Now, what as I mentioned earlier, the components in ventilators, the controller, it may be a microcontroller or PLC, depend upon your design. And this controller is interfaced with the valves, with the airflow sensors, the O2 sensors, the pressure sensors. Now, if you ask, I've mentioned humidity and temperature sensor. Now, these sensors are not used in each and every ventilator manufacturer. It depends upon the design, where now because there is a humidifier in before the ventilator, and the temperature, because when the air flow, it has to be that at what temperature the air is blowing. It's the standard room temperature, it is allowed, or it is the very below the room temperature or above the room temperature. So there are typical sensors like HIX series sensors, what we are using from Honeywell side, we propose. Pumps, motors, these are the basic thing. So basically, when this the valves before the valve, all these sensors are kept placed in front of the patient. Unfortunately, I was not able to add the flow diagram or the block diagram actual where the patient, the ventilators are placed, and how this block diagram works due to some constraint of my PPT and lack of time. I couldn't do that. I'm really sorry for that. But these are the typical components which are the ventilator manufacturer, or these are the basic components in the ventilator manufacturers. So if you see, all the manufacturers goes in this typical way. So this is the diagram. Okay. So this is the photo you can see. This is the fact. Fact means the factory acceptance test. I'm giving the full form to the students because the student may not know there are 2 types of tests. One is the fact, and second one is that. These are one of my customer, Shreyash Medical in Pune, who have manufactured the first ventilator when the pandemic started in the month of March. This is the prototype, and this prototype, if you see on the left side, there are 3 doctors which are assigned by the PMO, Prime Minister Office. Now, all these ventilator manufacturers have been assigned, funded, and monitored by the Prime Minister's Office. It means directly from Delhi. So you can understand the concern. Now, the major fact when we were talking with this customer or any other customers also, if you see that we asked them, sir, is this the government have assigned 1 lakh ventilators? So is this the typical requirement, or is this case going to rise? So he told that only 5%, 3 to 5% cases goes on ventilator, else all cases are normal. So still you can see the concern by the government is to manufacture more ventilators in case of emergency. So may these ventilators after this pandemic, this is going to help us to avoid future any disease. So you see, this is the typical ventilators which all manufacturers are right now making, from all your automobiles company, your other automation company, especially I would say the great contribution is from all the IITians, the IITians Powai, the IITians Kanpur, the IITians Kharagpur. All these guys who are known as the techno-savvy guy has given a huge contribution in the design of the ventilators in very short period of time. And you won't believe our country have done a very good job compared to the Europeans, compared to the USA, who are basically known as the pioneer for medical, but the talent in India have really, last 2 months when I'm talking with all OEM ventilators, the talent which our country possesses, no other country in the world has such a talent to develop such a beautiful ventilator in a short span of time. So believe me, all my audience, that India is having a bright future in medical in upcoming. There are lots of opportunities going to come in medical, because now where the industrial space is going down due to lack of funding and all, the people, all the automation manufacturers or consultants are now moving all their funds in the medical devices, maybe ventilators or any incubators. So this is going to be a booming industry in coming next 2 years. So if you're planning to make your career in the biomedical devices, it will be a really good choice from your package-wise and your opportunities and growth-wise. So this was from the ventilators. There were many things to speak about of ventilators. So you can, if you have any question about or doubt about this, you can note down and ask me before the session ends. So now, automation in agriculture. Now, what people will think, why agriculture? Now, as you know that agriculture is the backbone of a country. Once upon a time, it was the 75% economy before the GATT trade in India was introduced by our Dr. Manmohan Singh. The backbone of India economy was agriculture. Almost 75% economy was completely dependent on agriculture. So that was a slogan, that Jai Jawan, Jai Kisan, where the Kisan, the farmer, played a major role. But nowadays, the farmers are struggling. And why they are struggling? Because due to this climatic or geographical change. So that's the reason the government of India in 2014, they come up with the new scheme called Krishi Pradhan Mantri, in which they have a scheme called More Drop Per Crop. I repeat, the scheme name is More Drop Per Crop. If you Google, you will get it. So under this, the concept was to provide loans on the irrigation to the farmer. Before this, the loans were given only on tractors by the bank, maybe this Nationalized Bank, Scheduled Bank, or any private bank. So before that, the farmers used to go to the typical Saukar, and the Saukar used to charge a proper. And yes, we come in the automation in car parking. Now this comes under the automation in infrastructure. Now, what do you say about in city like where I stay in city like Mumbai, having a problem of car parking. Okay, people, due to the car parking, many of the people plan to take not a sedan car but a hatchback car. Why? Because parking problem. I have no parking in my lane. I have no parking at my office. That's the reason. We travel by train, but in train the overflow. So what to do? So even now we see to avoid the space constraint and everything, that is automation in parking. Basically, types of parking. Now, rotary parking and puzzle parking, you see these two diagrams. These are the two parking you can see in any complex, in your residential also, or in the office space also. And nowadays, it has come with the smart parking. I will come how the smart parking works. Now, this is the typical rotary parking where there is a stand over here, the slate you can call. The car enters in the slate and it goes up in the rotary way, and it comes down in the rotary way. So this is where it is used in the in premises like in the society, where there is a constraint of the space, and this puzzle parking are used in the malls or the office spaces. So what you can say, you will ask, what is the automation in this? So the main automation is this: you have this, all this goes on programming based. So how it's program based? So take an example of puzzle parking. Now in puzzle parking, I have a car above me, I have a car below me, and a car next to me. Now I have this WagonR, I have to remove this car. So this car has to go on the side or behind or upside or front. Then this plate will come down and I will be able to take it down. So all this goes to a PLC programming. And this PLC programming is done by the automation engineer. There are few strong companies. There are two strong companies in India. One is the RR Parkon, the group of Ramratan, RR Cable. Yeah, that is the RR Parkon is one of their entity. RR Parkon is strong in the car parking, is my customer, and 80% market share is of RR Parkon. And yes, Klaus is again a very good company who is doing nowadays in smart parking. So the first smart car parking project is coming in Hyderabad in one of the mall. I don't recollect the name of the mall, but yes, it is already initiated. So the smart car parking has been initiated. So like in both in rotary parking and puzzle parking, you require a PLC. And the second component, the measure two component, is the sensor. Now there are two types of sensors involved in this. First is the mechanical sensor, like limit switch, and second is the proxy sensor, non-contact type. In other words, proxy sensor is also called a non-contact type sensor, and limit switch is called a mechanical or a contact type sensor. Now, in case of puzzle parking or rotary parking, if you don't use PLC, doesn't harm. You can do on the normal base, on the pneumatic base also. But for me, the sensors, both the contact and non-contact type sensors like proxy and limit switch, are very, very, very important. Why? The sensor cost me around 200 rupees to 300 rupees or maximum 500 rupees. But that 500 rupees avoid a BMW car to fall from upside. The limit switch will limit the motion of a certain slate. So when this slate, if you see this empty slate moves to right side or left side or up or the front side or upside, it will restrict its movement. So when it restricts its movement, or in other words, when the slate is kept over here, the limit switch holds the slate. So this is how 300 rupees or 500 limit switch work, and it is connected to the PLC also. So this is how it works, and this is the important tool. So if the limit switch fails, okay, or the proxy sensor fail, the project, which is very costly, around one puzzle parking, a rotary parking of 10 parking comes around 15 to 20 lakh, and a car which is kept on, just imagine a BMW car, if it fail or fall down, you can see a huge loss. What can the company? So just rethink or imagine the engineering a limit switch use. So in automation we only knows like PLC, we only knows about SCADA, HMI, but nobody knows about the process variable. Limit switch is one of the process variables which plays an important role. And you won't believe all the machine manufacturing, they are using n number of type limit switches, because without limit switches, your machine can't work safely. So limit switch is basically a safety, having a safety feature. It is a safety component used. So when in future, when you recollect any parking or you can see any parking, just imagine that the parking is distant, not because of PLC, it's distant upon the limit switch. So this is the micro thing in the automation that I want to focus today. So the components in car parking, typical components are what I told you: the PLC, HMI, limit switch, proxy sensor, and the motors. Motors are drawn typically to the moment. So this is all about the car parking. Now I'm coming to the smart car, smart car parking. This concept of smart car parking in India only knows that if you go in mall, okay, number of parking car available, it is only 10 available, 90 is full. So this was the concept. If you go in Europe, it was implemented well behind or well ahead 30 years ago, smart car parking, where you get a token, and now an Android based, or if you're registered, if your number is registered in that mall, you will get a pre-alert message that today the parking slot status is about out of 500, 300 are full, 200 remaining, and it's a token, and it will also give you auto select whether which slate you want to go. So suppose the lower slate are empty, so it will suggest you that, sir, this is the diagram about, this is the complete blue diagram. So you can select the lower slate where you want your favorite place, and you can. So this is how the automation has come around. So now I'm coming to the very interesting topic about the IIoT. Now, IIoT, there are many things to talk in IIoT. IIoT stands for Industrial Internet Over Things. But the basic things, many of them don't know. People talk of IIoT, they develop the program, everything, they have the apps, everything. I can on my fan, my AC, my TV, on my mobile. But that is the virtual IoT you are doing. Actual IIoT is done by the sensors. That is why I have purposely wrote sensors in IIoT application. So when I talk about IIoT, there are the sensors who plays an important role. In other words, sensors are the heart of an IIoT application. Now, what we'll see, the first question, what is the difference between an IoT sensor and a normal sensor? Now, iVisit has a faculty, visiting faculty to many engineering colleges, as well as an external examiner in the final year projects or the third year projects. And where they show me very proudly, they develop the greenhouse effect project, and they tell us, sir, my project is the IoT based. Below, explain how it is. So this is the greenhouse where the humidity or the temperature is being monitored on my mobile, and I can send this to my cloud. So that's good. But this is the virtual one. This is not exactly what we are. So you can say that this is the light application you are doing, and basically the difference is what? So the sensor what you are using, the RTD or NTC or PTC, that sensors are the normal sensors. And what is the difference in IoT sensor? So the IoT sensors, like the proxy sensors, the pressure sensor, the water quality sensor, the gas sensor, the level sensor, IR sensor, and the ultrasonic sensors, they look like a normal sensor. But in that, they are having a chip called IODD chip. I repeat, the chip name is IODD. The IODD chip has the memory to store the GPG format, the PNG format, photos, take the reading, on real-time reading, I mean to say real-time reading, and it goes and store the memory, and the memory then later can be abstracted. This is the basic difference. So a normal sensor, they give the real-time. They give the real-time checking. In this, I also get the real-time and my memory is stored. So I also can get the complete image. And why IIoT? The question is, why you want the IoT-based application? Now, if you see, nowadays, the basic IoT application is going in the oil industry and gas industry. Why? Because when we ask the customer why you require IoT application, the simple question from Indian Oil, from Bharat Petroleum, from Hindustan Petroleum, and Reliance, all these four major players give me a common answer. And that was, sir, that we want to analyze things and want to become at the solution. Why? Solution they want because that is a huge theft of oil and gas. Gas, I may not be, but oil, yes, it is a precious well after gold. And you see the way the prices are rising day by day in the fuel industry, there is chances, no, not chances, I can say, there is a theft take place when the crude oil comes at the port, when the tankers are loaded. These tankers, when they move to the typical factories at the petrol pump, they theft the petrol. So a typical tanker size is around 50,000 liters. And if you theft around 50 liters, just imagine every tanker, they have thousands of tankers. IoT is having around 25,000 tankers. And if 50 liters every tanker is theft, just imagine the drivers will be more rich. They will give competition to Anil Ambani or Mukesh Ambani in the richness. So this is how the smuggling goes. So they want to monitor this, and because of the monitor, the sensors which are going to use in the tankers will be just sensors will sense, and typically the real time and the data feed in that will be going on their website, and based on that, the real time monitors will come place. So this is how these sensors which are used in IIoT application. Another application I like to share in railways. You must be heard, or you must have traveled from Konkan Railway. The basic threat to the Konkan Railways is about the landslide, especially in the monsoon season. So typically the season from June to December are the critical period in the Kokan railway, and that's the reason when it enters in the tunnel, the speed is drastically reduces in the compared to the normal period. Now they have implemented using sensors over there, which are IoT application, which every 10 meters or 5 meters, and this is going to give you the indication of the landslide of Earth. So basically, this is going to give you the predictive and the preventive maintenance. This is what the IoT plays an important role. So as an automation and instrumentation engineer, when next time when you come across any student, you have to tell them, or any person in project, what is the difference of IoT sensors and a normal sensor, whether your sensor is having the IODD chip, and can I take the image, or can I store the data in this with respect with some memory space. So this is all about the IoT application. If you have any questions, you can note down. I'm there to answer your all questions. So this is the last session, and this is a very important track and trace in pharma industry. Now, the word suggests track and trace. It means tracking, that I am spying someone and I'm tracing him. So what exactly it means? So it is called an ITS. So basically, it was implemented a Turkish pharmaceutical, a track and trace, generally abbreviated as ITS. In India, it is called track and trace. Defined infrastructure constructed to track and trace units belong to each pharmaceutical product. ITS application is an infrastructure which is known track and trace for the data matrix code. Now, what happened is, take an example of a Cipla. Cipla is having n number of pharmaceutical products for each and every disease. For example, for blood pressure, they're having n number of brands, n number of capsules, and each of them has having a different batch and different batch code. So if you recollect a long back around 10 years back, 1D code were printed on all your pharmaceuticals or your medicines. But now it comes in the 2D code. So if you see, these are the 1D code. Now it comes in the 2D code or QR code. So this is the change of technology it comes. So let's see how it works and how the track and trace plays an important role. What is the advantage? Ensure the reliable supply of the drugs to the patient. It means the proper drug supply should be to the patient, ensuring that is recurring, prevent and counterfeiting fraud, smuggling. In India or in world, pharmaceutical, the smuggling pharmaceutical is after the goal. You can see the smuggling comes in pharmaceutical, and many duplicates medicines are in market. Prevent barcode scam. So this is the main reason why the barcode scanner has been introduced for the QR code. Support rational drug use, supply data to the control market. So the rational drugs which are coming, so proper drugs like in India, who is the strongest in the API. We are number one in exporting the drug, ensuring that controlling the market, no monopoly in the market. So the basic concept is every single box of a drug or the medicine, it defines a unique box of pharmaceutical interest. So every box will be traced in this. The GTIN, if you see on the medicine, there will be a GTIN code, low trade item number. So this is a unique number, and this has been used for tracing. Ensure the uniqueness of the drug universally. Sterilization number printed on the box, and the GTN asset ensure the uniqueness of the single box. Every damn single box of the medicines of each and every company of every plant will be different, and it will be traced. Participant, a person, group, or organization will be participant. Now let's see how it works. So this is the typical. This was my project. When I was in Omron Automation, it was a Propex, my channel partner, who done a project. So this is the line, a production line of a pharmaceutical. So if you see, this is the camera, vision camera. Okay, and these are the sensors. So when the tablets come here, the vision camera clicks. The vision camera clicks the images, and these images and the sensors sense. These images goes in my HMI or the vision screen. It is a vision screen, we can say, but rather than HMI for the camera. This is the interface with the camera. Now, this camera, a special camera, track and trace camera, which is having a high capturing speed. This is not a normal camera, a high capturing speed. So this they can click around. Suppose the line speed of a pharmaceutical company is 100. It means that 100, it goes on the speed of 100 and it clicks and it comes. So every time when it clicks, it has been teach. Teach means the typical area of a medicine has been pre-fitted in my system and it will click. And the click area is of the QR code. You will see each and everything, such as the GTN number, the batch, the expiry SN, everything. And this data is split in the cloud, in the global cloud. Then it goes in the carton. Again, the carton is having the second QR code because this is the typical individual QR code. This is the carton is having the QR code. Okay. Again, the QR code is having the same thing. We're going to repeat. Again, third one, when it comes to the big carton, again, the same thing going to repeat. So just imagine the 3 QR code has been implemented. First at the individual level, then the carton level and main box level. So suppose when this box, the last one box, goes to the any wholesale dealer, because there are reseller dealer, it will be traced. Now you will say, so what is the use of this? Now suppose you buy a Crocin in a nearby chemist. After consuming that, okay, the date, expiry date was well in control, everything was well in control. After consuming that, you are feeling uneasy or there is a side effect. You admit it and you claim that this medicine was consumed, it was taken from so-and-so chemist, and it is under the expiry date. So you can go back to the chemist and tell boss, I faced the problem because of this, and he will trace when it was manufactured, the batch code, everything, it goes in the server. I will show in the next diagram. This is how the typical production line of pharmaceutical is. The line integration, okay, generation of the serial UID at multiple level and integration. So this is the core, this is the thing which is very important in your medicine. Now, if you recollect 2 months back when the hydroxychloroquine was banned from India, okay, and Trump asked to our Honorable Prime Minister to start the supply, there was a news on the social media that India have asked to ease the rule of FDA, US FDA. Now, the US FDA, whenever the Indian companies as of now are struggling to export maximum of their ready-made medicines to the US continent, the problem is that because US FDA wants that the Indian manufacturing are not up to the mark of the standard of US FDA. Now, what this say about? So, in India, Sun Pharma and Cipla, they have absorbed this US FDA. Now, I will take you back when I was working in Mitsubishi and I was handling this project, a company called Sun Pharma. In overnight, there was a ban by US FDA that none of the product will be allowed on the US continent or Europe continent. They were shocked. Why? Because your product, your production facilities are not up to the US FDA mark. So what to do? Yes, you have to come up to you have to upgrade. So what's the upgradation? That your GTN number, your expiry date have to track, and track and trace application has been should be implemented. So after that, within a span of 6 months, Sun Pharma, the Halol plant, they upgraded their plant. Almost 500 machines were upgraded, and they come up to the mark of US FDA. Then the Cipla was the second one in 2016. In the Cipla, the Patalganga plant implemented, and all the plants came. And now, slowly, all other companies are coming because see, in pharma, implementing all these things, it's a huge cost, and to implement a huge cost, you also require the budget. So in this, you can see that high-speed vision inspection system to perform the multi-camera. So almost 4 to 6 camera, which I told you in my previous slide, 4 to 6 camera on a single line have to implement it. A cost of a single camera is around 2 lakhs. Just imagine, one camera will cost you around 2 lakhs. 4 to 6 camera in a single line. And there are how many lines? There are multiple lines. Like, for example, take an example, 10 lines. So 10 into minimum 4. So 40 cameras at a time for the 10 lines. A huge investment. This is only if I'm talking about the camera. Again, you are having your cloud license camera. Okay, your high-speed resolution vision machine. Everything has to be implemented and upgraded. So this is what the cost is involved. So typically, if you want to invest in 10 lines of upgrade, your budget should be more than 5 to 10 crores. This is what the pharma industry was struggling. But luckily, Indian pharma industry identified the challenge and they have made all these changes. So this is how the typical collection works. Typical the local pharmacy, okay, when he will track and trace, he will connect to the global server. So this is a pharmaceutical plant. When they dispatch it, the pharmaceutical, there is a wholesale pharmaceutical in between. So they will know which batch it was manufactured, at what time, who was the operator handling this, and when it was introduced in the pharmaceutical wholesale, when it was distributed. So the thing will definitely move slowly to the manufacturing plant. In which plant? Suppose a Cipla medicine malfunction. So it was manufactured in which plant of Cipla? Whether it was the Pithampur plant, whether it was in Patalganga plant or any other plant. Once the plant is identified, they will identify the batch number on which day and who was the operator, who was the engineer, who was sitting in the control room, and they will take the trends of the SCADA and everything will be investigated and they will come to know. So this is what the US, this is the implementation of US FDA. So they know the life of the human being is precious, and that's the reason all the data collection is in the micromanagement system. So in India, they've already started. If you see your medicine, that you will find the QR code, the 2D code has been implemented. So this was all from my side. So this is now the harassing session. Like you will like to ask a question, you are open to ask. Yeah, you can. Yeah, team. There is a video which was of ventilator application that I promised to share you. So this is very interesting. This is the prototype of ventilator. Okay, okay. Yeah. Just let me know when it started. Okay. Started? Okay, okay. So basically, you can see this is the HMI, and on this HMI, you are controlling all your graphs and the patient. So normally, this is the prototype. No patient is connected, but instead of patient, I am using this. This is the lung. Okay, I'm blowing there. I'm contracting, expanding. Just see. Okay, this is the ventilator. This is the top part of ventilator, and where they have feed the recipes, different recipes, and this is the recipes reading. You can see the graph, the reading of the airflow and the pressure is monitoring to where the respiratory of the patient is monitored by the doctors. These are the different settings you can see. The graphs go, I can see patient monitoring life
at
condition.
Median Healthcare have developed this basic ventilator for the current outbreak.
So basically,
This
what I
here
mentioned
is PCB
earlier,
is a
why
microprocessor
they are
controlled
doing on this
with a
glove,
pressure sensor
because they
monitoring.
almost do on bellows. In the
This is
next
the
video, you can
pneumatic
see the
manifold.
bellows, because our lungs are
This is the
basically made
patient
of this.
airway,
They expand,
breathing
contract.
valve, and the test
Okay,
lung.
so that's the reason
This
when
is the
we
display,
inhale. This is the second video.
display, and
These are the
analog
cards. This is the
pressure airway pressure
design
monitoring.
of the ventilators
These are the
inside.
settings
So you
for
can see
the
the
pressure
sensors have
limit,
been put over there.
frequency, and
This is
minute
my
volume.
card, which is interface with the other card. Then you can see the valve over there. Where the tubes have been connected. Pressure gauge to monitor, to ensure the pressure.
So we can adjust the frequency.
So this is what
And we can adjust the
the
minute volume.
design. So as I mentioned in my PPT, in ventilators you don't have some rocket science in this, and I've missed one point that there was a news 8 days back in the newspaper that see the bellow. You can see it is expanding, it is contracting. This is how the patient inhale and exhale. So this is what the prototype is all about. So I was mentioning that NASA, the space heroes of the world, NASA, has been transferred the technology of the ventilator making to one of the Indian company, 3 Indian companies, in which one of the automobile companies.
Airway pressure monitoring.
Yeah.
These are the settings for the pressure
many
limit,
final year student can do.
frequency,
Disappointment I
and
can see in
volume.
final year student that they go on a very basic project. So they should take risk because you are in seniors, you are the futures of country. You need to do some great project. What I've seen, like you can go on the medical. So one thing I observed that
So we can
instrumentation
adjust the
students,
frequency.
they don't go on any biomedical project. They had a biomedical subject, but they don't go on biomedical project. They can go on biomedical project. Many they can go on the basic incubators and all, or they can go on some IoT project, real
we can
IoT
adjust the
project,
minute
not
volume.
the basic project. So there are many projects to discuss. It completely depends upon the interest and the budget of the student. The next question: which are the free software of PLC and SCADA? As of now, in the world, there is nothing has such free, you can say. But there are some brands, there are some makes like Omron Automation. They are having their free trial version of 1 month on online, so you can download it and you can have for 1 month. But PLC and software, this is the cost where the company margins are attached. So I have never come across any free PLC software for SCADA and PLC, but you can there are some trial version for 1 month. You can try for Omron Automation. What is the cost of this ventilator currently? Now, this is the very tricky question. Hope so. It may not be a competitor of any ventilator manufacturer. This question answer. So see, basically, Mahindra claims. If you see the news, Mahindra claims that we have manufactured ventilators around 5,000 to 10,000. But basically, the story behind this was different. Now, Mahindra just developed a prototype in which sensors, the valves were not there. So the sensors cost you around more than 10,000, and a minimum ventilator, even if you reduce the cost, everything, a minimum ventilator costs you around 80,000 minimum. And if you go for the PLC additional, the HMI, and very high tech ventilator, it will cost you around about 2 lakhs, 3 lakhs. It completely depends upon what kind of BOM, bill of material, you are adding in it. Sir, can you suggest a brief about the IIoT sensor? So basically, it is not an IIoT sensor. It is the IIoT sensor with IODD chip. So what brief you want? So basically, it's a sensor which look normal, what you look like. Okay, but in that, if you open, there is a chip inside. Okay, so that's the reason. The cost-wise, the normal proxy sensor cost you around 100 rupees, 200 rupees. If you go for a brand, 500 rupees, and maybe the IODD will be the IoT sensors cost you around 1,200, 1,500, depend upon the make and all. So this is what a brief. More brief, if you want, you can connect me personally or my email ID or cell number, so I can. It was not possible to share all the PPT on this session. So those who have asked this question of IODD sensor, they can take my number from the organizers, and you can call me in after 6 o'clock. Any other questions? Okay, I've got one question. We are falling short of ventilator during COVID in India. Is there any application done so that one ventilator can supply more patients? Will be feasible for monitoring? First of all, I would say that not feeling short of ventilators. Okay, the reason is you will say why, sir? People have been died. So first of all, I told you 3 to 5% cases goes only on ventilator. Now, the problem was that in India we didn't focus on medical investment. That's the reason. So if you say that the ventilators, what India have ordered is around 1 lakh. 1 lakh ventilators are in the phase of manufacturing from Maruti, from Tata, from Bharat Forge, all these big giants, and from ventilators like Hedwa Healthcare, everything. Now, if you see, hardly in this, what I have my knowledge and what I am investigating from last 3 months, 25,000 ventilators are only going to use in the worst case. The peak in India has started now. We are getting 10,000 cases every day. End of this June, it is expected that the peak will be 25,000 cases per week. It is predicted. I'm not sure. It is predicted, and I've read this from the reports from ICMR or any other Georgia University expert too. So, and this peak don't last more than 3 weeks. It will be 2 to 3 weeks peak, and the peak goes high. Now, if you see in any other country, okay, they had adequate amount of ventilators. People died don't know about ventilators. People die because of the negligence. In India also, nowadays, the cases which are getting more, they are getting identified at initial stage. But if the report also says if I'm positive, okay, I will be cured in initial stage. But I goes in my very rare case in India. Just have a look. The cases on the critical on ventilators are very low as of now. There are ventilators, and I think so. The first lot of ventilators around 2,000 to 3,000 has been dispatched by Maruti very soon. Because see what happened, all this company started manufacturing. The RM, the raw material, has also to be arranged. And the question was like, can suffice more patient? Any application though, so that one ventilator can suffice more patient, will it be feasible for monitoring? Unfortunately, one ventilator is used for only one patient only. Very sad to say. 8 days back, my auntie, my mother's sister, she also got expired because of coronavirus. When we investigated, the cause was not for all ventilators. She was admitted in ICU, but if you are having a disease like high BP, high blood pressure, even the ventilators will not be helpful to save your life. This is the basic concept. So please type it chip name. So there is no chip name as of now. The chip itself is called IODD chip. So when you buy, so for example, like if you say a PLC, okay, it's a you decide kind of you want. You want a modular PLC. You want a brick type. If you approach Omron Automation, they are expert in this proxy sensors of IoT chip. You say, sir, I want a proxy sensor from you, but I want IoT version. So it is inbuilt. So when they manufacture, it's inbuilt. Like no has chip name is different like this. Any other questions? Which no, as of now, no questions I have from anyone. Okay. Yeah, tell me. Yeah. Okay. So I will take. Thanks a lot for joining my session. If you have any doubts or more clarity you want, you can take my number from the organizers and you can contact. Thank you.
Hello all. I am Mrs. Mugdha Salvi, Assistant Professor with the Department of Instrumentation at Vidyavardhini's College of Engineering and Technology. I am here to present a vote of thanks to our speaker for the first session, Mr. Rishikesh Bhagat. Thank you very much, sir, for this informative session. You introduced us to the applications of automation in various fields, such as agriculture, pharmaceutical, medical, infrastructure, and IIoT. In the time of this pandemic, COVID-19, ventilators are very important for treatment of patients. You explained us various concepts of the operation of ventilators as well as how automation plays a major role in the operation of ventilators. Agriculture is the next most important field, and as India is an agriculture based country, automation will truly help our farmers to boost their yield and help them grow. There is so much space crunch nowadays that car parking is become very hectic, and having such beautiful car parking systems which are utilizing so small space is obviously going to be a boon to all the people staying in the urban areas. You explained us what is the difference between a normal sensor and a sensor that is used for IoT. You explained us various concepts which are more important as a sensor for IoT. It is also true that you explained a new concept to us, the track and trace system, the ITS, the Turkish pharmaceutical system, which is so much useful in nowadays to track exactly where the logistics is moving. Thank you very much, sir. It was a pleasure listening to you, and I'm sure that all our participants have also enjoyed this session. Thank you again. And now, let's move on to the next session of our day. I would like to introduce you all to our speaker for the next session, Mr. Soju Sasindran. He is an EXTC graduate and working.
Good morning, everyone. Hope everyone is safe and healthy and following the guidelines given by the government. My name is Soju Sasindran. I'm working for Omron Automation Private Limited for the past 9 years. I'm working as a senior product trainer. First, let me thank Vidyavardhini College of Engineering and Technology for giving us an opportunity to be part of the faculty development program Automatus 2020. My topic for today is PLC basics. My presentation will take 1 to 1.5 hours maximum. In this presentation, I will explain the basics of PLC, the components used in PLC, the use of PLC in industry with relevant examples. So let me take you through the presentation. Thank you. brief you about few things about Omron. So if you see the Omron automation, we have started our operations in India from 1996 onwards through our channel partners. Then in 2006, we have started our offices in India. Now we have total 8 offices across India, all our regional offices. So we do sales and marketing there. And if you see the Omron product portfolio, we have more than 2 lakh products in our portfolio. So you can just imagine the list of products available with us. The main areas being automation systems. Then we have industrial control components, vision system mainly used in QI and QC, quality inspection purpose. Then we have safety components, which we use for safety purpose in all industry. Then the final part which we added is robotics. So if you see, we have from very small relays to high-end controllers, which we can compete with anyone in the world currently. Okay. So without further delay, I'll take you to the PPT. So now until mid 1970s, most machines were controlled basically used by the relay systems, which were housed in very large electrical panels. Okay, so many issues were there when you are doing the wiring for the relays. If you want to make any modification, it was a hectic job. So the invention of PLC originated when there came a request from automobile manufacturer General Motors. So their request came in 1968. So many people were working on that. One, Mr. Richard D. Morley, he was also working on that during that period. So he came up with the idea of digital or solid state controllers, which was PLC. So the PLC came into existence in 1969. Okay, so this was the first PLC introduced, and later that company was named to Modicon, which currently Schneider is owning. And if you talk about Omron, we have introduced PLC by 1972. So the first PLC we introduced in 1972. So what is basically a PLC? PLC is a solid state device which simulates electrical components including standard relays, latching relays, electronic timers, counters, and other components, or it's a digital electronic device with a programmable memory. So based on your logic, based on the input devices you connect, the logic you develop, the outputs which are connected, accordingly you can build a digital electronic device with a programmable memory. So you can see the slides. So a digital electronic device with a programmable memory for storing instructions to implement special functions such as logic, sequencing, timing, counting, and arithmetic operations. All these things can be programmed using your PLC. Another thing is PLCs operate according to user program internal logic. As I told you, you have the facility to program the logic in PLC. But if you see, let's talk about the relay-based system or the hardware type control panels. So if you want to make any small modification, so much work is involved in that. So much wiring will be there. And sometimes what happens if there is small disconnection from the panel, you may have to backtrace all the way to the panel. So it was a very hectic job. So now came the PLC. So the PLC reacts to changes in signal sources such as push button. So if you talk about PLC, there are mainly 3 things to consider. One is the input interface, where you are going to connect input devices such as push button, then switches, limit switches, all kind of switches, sensors, all these are considered as an input. So we have input interface, then we have a controller, that is your PLC CPU, then we have output devices or output interface, where you can give the indication using indicator lamp or relay system or solenoid valve. All these will be considered, or motors, all these are considered as. So basically if you consider, we have input, then you have logic, then we have output. These are the main things related to a PLC. Now let's see the PLC block diagram. Okay, so if you consider the block diagram, so when we talk about PLC, why we have introduced PLC in industry? Earlier we had relay system, then there came a requirement like we need a more rugged system which can be programmed. But why PC can be used in an industry? Because PCs are unreliable in industrial environment. So we cannot go ahead with the PC based system in industry if the environment is not good. So we came up with the more rugged model, that is a PLC. So let's see the PLC block diagram. It is similar to your desktop PC which you use in your home. So we'll be having an input interface just like you have a keyboard, then we have mouse, then you have a CPU. That is basically the PLC CPU what we have. So microcontrollers will be inside. So memory, CPU, then power supply should be given to the CPU. Then you have a display, that is your display screen. We have output devices. So if you compare it with PC, it's similar to PC only. We have input interface, we have a controller, that is a CPU, then we have a output interface. If you talk about PLC, we have input interface. Similarly, we have a CPU, wherein you have to give the power supply to the CPU. Then we have output devices. So in the CPU, we have memory areas, memory in storage size also may differ. So we have memory, then we have a CPU. So these are the components, PLC block diagram you can find in the slide. We have input interface, then the CPU, then the output interface. So you can see the components used. So in the input you can see we have used limit switches, proximity switch, read switch, level, push button. Then we have micro, that is CPU part, then output, relay contactors, then solenoid and lamps. Before going further, I would like to explain is when you talk about the CPU part or the controller, normally in PLC we use application specific IC. So that is known as ASIC. So application specific integrated chip will be used inside a PLC, not the microcontroller based system. Earlier it was not used. Earlier it was only application specific IC. But now if you see, if we talk about Omron, we have introduced our Intel based system from 2011 onwards. So if you see, we have high-end controllers, which one of the most sophisticated controllers we have right now, which is operated by Intel Core processor. So i7 processor we have in our controller now. So similarly in old system we had microprocessors, that is ASICs were used, application specific ICs. Coming to the input interfaces which we normally use. If we talk about PLC, normally we discuss only about digital input or discrete input. In discrete input, we normally have only on or off condition. This is either 0 or 1. Just like you have in PC, you have binary 0 or 1 system. Similarly, in PLC also, we normally prefer discrete inputs, that is either 0 or 1. So digital inputs either on or off. So you have toggle switches, you have push buttons. In those conditions, you will get only 0 or 1. When the toggle switch is off, it will be 0. When you switch it on, it will be 1. And another set of input devices what we have, that we call it analog input. This is an analog input which varies continuously with time. That is, if you consider pressure sensor, temperature sensor, flow or level switches, those switches operate when the voltage or current is continuously varying. That is, you have different variety of analog inputs, either voltage or current. So you may either have 0 to 10 volt, you may have 4 to 20 or minus 10 to 10 volt. So normally we use it for temperature sensors, pressure sensors, flow detection, flow sensor or level indicators. If we talk about the output devices, we have similarly, we have digital outputs and analog outputs also. Digital outputs, same thing only, either on or off, whether it's a signal for a lamp or if it's indicator lamp or any other. If you want to switch any relays, if you want to operate the solenoid valve, if you want to do some other purpose, you can use the digital output. Or similarly, we have analog outputs also, wherein it varies continuously with time. That is 0 to 10 volt for a heater. So it's always continuously varying. Okay. So now we will discuss about the advantages of PLC. So what are the advantages of PLC when we consider it with the conventional panels? So you can see from the figure. Hello. So you can see from the figure that we have so many advantages when we are using a PLC. So if you see the conventional panels which we use years back, okay, so everything is relay-based logic. Now also, if you talk about PLC, we have ladder-based logic also, which is similar to the connectivity what we do in relays. We are using contacts and coils in that also. But if you consider the amount of wiring used in the conventional panels is very large scale wiring required, and if you want to modify a small logic, then also it involves so much wiring in that. So without PLC, it is necessary to rewire devices to change operation of machines. So with PLC, what we can do is simply you can change the logic from your PC or your laptop, and you can directly program it with the PLC. Only minor changes are required. We are not saying we can completely remove the wiring part, but wiring will be limited. So what are the advantages we have compared to the conventional panels? So we have smaller chip and more flexible than their hardware equivalent. Then diagnostic function. This is a very important function. Diagnostic function makes monitoring and troubleshooting very easy. So the thing is, if you want to troubleshoot any miswiring or any loose connection or something, you have to backtrace the whole thing back to the control panel. But in this case, PLC, if you do something wrong, automatically you can check that in the troubleshooting part. While developing the logic, if you are making any mistake, the PLC program, from the program you will get the alarm black. You are making something wrong. The third one is less wiring compared to the conventional panels. So we are talking about less wiring, not the completely we can avoid the wiring part. Then power consumption is far less if you are using a PLC compared to relays. If you are using power relays which ampere rating more, then more power will be required for that. But for PLC, we use components or we use connectivities. PLC operate with 24 volt DC most of the cases. Then fast scan time improves machine cycle time. Another big thing that has happened is the scan time, which has improved drastically over the years. Earlier we had in microseconds. Nowadays, if you see the controllers, we are going in nanoseconds. So you can just imagine the speed with which data is transferred. Then documentation can be easily printed. That is, if you have developed a logic in ladder logic or any other logic. So what we can do is, if you want to take anything or you want to make a manual out of it, you can simply print the logic directly from the software. Now coming to the things the PLC can do. Okay, so what all things PLC can do? The main thing is, if you talk about PLC is basically programmable logic controller. So what it can do is it can do sequence programming. So if you are going to write a sequence, so based on that sequence, the next line you will write. So let's say I'm going to take example. So I'm going to light a lamp using an input. So I'll be taking an input, contact of an input, then I'll give it to a coil. So okay. So once the contact is enabled, then coil is enabled. So you will lit the lamp. After the lamp is lit, after that you want to operate something else. Let's say after a delay of 5 seconds, then you want to operate something. So what you can do is you can take the output, then you can give it to a timer. The timer will operate for 5 seconds. After 5 seconds, you can again operate something else. Let's say I want to switch on the motor, sequential motor operations. So I will switch on the motor after the delay of 5 seconds. So you are writing delays sequence one by one. So first line you will be writing the logic for switching on the lamp. Second line you are writing the logic to switch on the motor. So this is basically the sequence control. So you can see on my screen. So what are the things PLC can do? Basically 3 things normally PLC is doing. One is sequence control, where relay logic replacement. That is basically you are developing the logic. The timers and counters can be utilized in a program. Then you can develop auto and semi-auto and manual control of machine and processes. If you want to write a logic for a complete automatic system, that is possible. If you want to make a semi, and with your intervention, if you want to do something, that is also possible. Let's say if some error comes, you're going to reset it. The system, you don't want system to reset it automatically. That also can be done. The third one is manual control of machines. You would have seen some machine operations like some robo operations you will be doing, or some press machines. I'm talking about press machines. Press machines, you have to do it with two arm switches. That two handheld switches will be there. So basically you are doing it manually. So manual control of machine process can also be done. Like I'm talking about the press machine, then mainly press machines only. So those things you can do with the help of a PLC. You will develop a logic inside the machine, and then machine will be the process or your press machine and giving the input to the machine. Second one is a sophisticated control, where you are going to develop logic for arithmetic operations. Then information handling, if you want to transfer the data to, let's say, HMI or some other system. Then analog and PLC control. These are basically the analog values which are coming from PC. Maybe from field, the analog values will come. The PLC will convert it into digital format, and accordingly it will map. So we call it as scaling. Then we have servo and stepper motor control. That also can be done. So sophisticated motor applications or positioning applications can be done with the help of PLC. Third one is the supervisory control. As first session you would have seen in the starting of the inauguration of FPP, we had a session for SCADA. So that is basically supervisory control and data acquisition. So that can also be done with the help of your PLC. So process monitoring and alarms, basically the data which is fed to the SCADA system will be provided by the controller. Not only the PLC, maybe high-end controllers like machine automation controllers can be utilized for this. So process monitoring and alarm functions can be done through our PLC. Then fault diagnosis and troubleshooting. Nowadays, so many controllers are coming, or so many controllers have given the provision to give this fault diagnosis and troubleshooting part in some other system, let's say graphical interface system like HMIs or SCADA, where you can directly map the values to that particular system. So fault diagnosis and troubleshooting, it becomes easy. Then printing and documentation and ASCII support. Then factory automation network. So let's say I want to transfer the data to SCADA. I want to transfer the data to the database system, which is there in a factory. So complete automation can be done with the help of a PLC. So I'll give you an example. Let's say I'm having 10 machines in a line, in a production line. So I'm having 10 machines. All the 10 machines are connected through PLCs. Let's say it is connected through the internet network, or you can connect through Ethernet IP network. Normally in industry we use Ethernet IP now. So Ethernet IP network. So all the data is connected through Ethernet. So we'll be collecting the data through Ethernet IP and will be given to a center or a master PLC. Then master PLC will communicate with the database. So earlier systems, we need to use intermediate system or a PC based system which can translate this data which is coming from PLC, and then it can transfer the data to database. But now if you see most of the controllers, even Omron is having controller which is having the capability of transferring data directly to database. So we have high-end controllers wherein you can simply write the logic and this controller will directly push the data to database. Whether it's MySQL, SQL Server or Oracle DB, all the databases you can push the data directly. So factory automation network is also coming under your PLC. Now coming to the application areas, you would have seen so many areas where PLC is utilized. You can see it in material handling, food processing, food and beverage, then power plants, pharmaceutical. In pharmaceutical, you would have seen the automated line. You would have seen the packing of the capsules or vials. Everything is done. So if you see paper and pulp industry, automatic rolling of the papers, then robotics. Robotics, you can see almost in all industry now robotics are available. There are some places where it's autonomously done by the robot without any human intervention. So petrochemical boil. So these are some of the areas where you can utilize it. So Omron, we now mainly focus on automation areas or machine automation areas. So we have some presence in process industry also, but mainly our areas are machine automation, wherein we give all kind of solutions. So now let's see, I'll give a small example. So this is one example wherein you are using the PLC to control the transfer of this food. Let's say this is a restaurant or the hotel segment, wherein this is a very simple application. So let's see. So PLC control the motor to carry food and dishes. Oh, am I audible now? So now you can see the slide. The PLC control the motor to carry food and dishes according to the input from the push button. Now let's see. When the elevator is pushed by the server, the elevator starts moving to the floor below. And when it is pushed back with the dishes, it comes back to the floor again, so that the person can serve the food to the customer. So in this, simple PLC is used, and these operations are carried out by the motor. Okay, so you need to use a contactor if you want to switch a large loads. For small loads, relays are sufficient. If you want to use large loads, then always it's better to go with the contactor. Okay, now I'll give a live example, or not the live example, one simple example in the bottling line, where how or different operations are happening in the line. So we'll see the example. So our machines operated in a factory. So if you take any factory or any industry, everywhere the PLC will be involved. No matter how which make they are using, people will be utilizing PLCs everywhere. Now let's see this process. So this is one process. This is a bottling line. Okay, in the bottling line you can see different process involved in this. First one is the bottling and capper process. Second one is the shrink labeling process. Third one you have packaging, or before that we have time stamping process, where you will print the barcode, then you'll print the manufacture date, batch code, and then it will go to packaging process, where these bottles are packed, and then to the casing process for the final dispatch. Now in the capping and bottling and capper process, what exactly happens? So once the bottle is set under the nozzle, so whenever you are filling any liquid in the bottle, first the bottle will be coming as empty. So once the bottle reaches, then using the nozzle, you will be filling the liquid in that particular bottle. Once the liquid is filled, so many products are used for this purpose. Okay, using mortar in that. So you are using the mortar to move the conveyors. If you don't want precision in that, you can utilize variable frequency drive, but this will be liquid. So after filling the liquid, you can check whether it's properly filled or the amount of liquid which is entering the bottle is proper or not. That if you want to take the confirmation, you can use the vision system in that. Using the vision system, you can use it. So once it is done, the cap is closed, and it will be going to the next session. So when an empty bottle is set, the content is filled and the capping machine seals the top of bottles. So this is the first process what we are doing in a bottling line. So you can see when an empty bottle is set, the content, that is either water, juice or anything else, is filled and a capping machine seals the top of bottles. So this is the first process which is done. So once this process is done, it will go to the labeling part. So labeling part, what it is you would have seen so many products coming up. Let's talk about aerated drinks only. You have Coca-Cola, you have Pepsi, you have Fanta, so many things are there. So how it is defined? So you can see the label on top of that. Again, the color also will be different. So next thing is the labeling process. The labeling process, the sensor detects the thickness of the sheet roll. Okay, and then you can see the products involved in this. You can see the sensors which are there. Then you can see a control panel on top that you have a hooter or you have an alarm system. Now the filled bottle, when it comes to this section of the line, a filled and sealed bottle is covered with a tube shaped label. If it's a round bottle, you will have a tube shaped label, and hot air is used to shrink the label closely. Once it is attached, then it will be shrinked. So this is basically the shrinking and labeling process. So you can see on the figure which is popped up, there you can see the roll of labels which are given. So you can see the sensor attached along with that. So this sensor will basically checking the roll size of this label. So when it reaches the minimum size, then again it will give the error, and the hooter which is attached along with this panel will give the alarm. Then the operator will come to know it is time for him to change the roll. So this is the second part of this line where you do the labeling part. Now coming to the time stamping process. In time stamping process, what it does is basically prints the code in this label. Okay, let's say label will be there with the name, with the content, everything. But what about the production time? So when you consume any material, let's say if it's a bottle or if it's a carton box or if it's a Tetra Pak, you can see the manufacturing date. You can see the batch code. You can see so many details available on the. So how it is done? So it's basically a laser printer which prints the manufacturing time and date on the bottle. So once the sensor detects a bottle, PLC can operate this. PLC operates on printing machines to it will give the command to print the manufacturing date. So this is the time stamping process. So you would have seen this batch code, time, everything on this PLC now. Now coming to the packaging process. So once the print is done, a certain number of bottles are gathered. Let's say you have a pack of 6 or you have a pack of 10. So how it is done or how it is packed in a carton box. A certain number of bottles are gathered and a cargo handling machine carries this bottle into a carton box. Now you can see so many things are there. So let's assume we have a pack of 6. So I need 6 bottles per carton box. So how it is done? It is done through PLC. So what it does is it will be having a counter. So when the count goes to 1, 2, 3, 4, 5, 6, once 6 is done, it will give a command. Then this operation will whatever cargo handling machine is there, cargo handling will take all the 6 bottles and will pack it in the carton box and will be transferred to the next line. During that time, let's have a limit switch or some other stopping mechanism will be there on the conveyor where it stops the rest of the bottle from entering the area. Once it is packed, then again we'll get the go ahead signal. Then the next 6 bottles will be taken and it will be stored in the carton box. Now the last process is the casing process. In this casing process, you can see the carton box as some. So the earlier machines you were having cargo handling. Now, if you see the latest thing that is happening is Robo is doing all this work. Even the packing part, sealing part, everything can be done with the help of a Robo. So if you are using an articulated Robo, 6-axis Robo, the 6-axis Robo with the help of a gripper, it can pick and place all the bottles in the carton box, and it can do the sealing part also. So in different lines or different production lines, you can see different advancement with respect to different areas. Okay. Earlier we were having PLC, which is having only serial communication, that is point to point. Then it went to RS485. So many advancements have happened. Nowadays we are using Ethernet IP and EtherCAT for device level operations. So I'll talk about EtherCAT. EtherCAT is now one of the fastest network available for devices. So device level network, EtherCAT is one of the fastest network available now. It is having the same speed as Ethernet IP, 100 Mbps speed is available. So many advancements have happened areas of automation. So now talking about PLC. So today's topic is basically PLC. So I've just given an overview of the production line, one simple production line. So many areas are there where PLC can be utilized. Like we have machine industry, then machine tool industry, automotive industry, then we have F&B, food and beverage industry, FMCG. So many areas are there where we can utilize the programmable logic controllers. Now coming to the selecting the right PLC. So you guys have heard about PLC, how it came into existence, what are the components used, but how to select a right PLC, that is up to you. Okay, so when you have a requirement, if in industry point of view, for students who are going to learn about PLC, there are so many things you have to learn, or so many things are there which you can learn, because so many PLCs are available in the market now. So each PLC will have its own advantages, its own so many good points. So how you are going to select a right PLC? This is a common points which you can utilize when you are selecting a PLC. First thing is the application type. So you need to check for the application type, in which particular industry are going to use this particular PLC. So selecting a right PLC. So you have a packaging industry. Okay. If you are in a packaging industry, you will require high speed counter input or pulse train output. So you may need to use high speed inputs there. If you are talking about the process control, so in that case, so many valves will be there. So many things will be controlled using analog values. So you have to go with analog. Then if it's a load cell application where you need precision, then you need load cell application based, or the devices or the modules which you use should be compatible with the PLC. So first and foremost thing is the application type before selecting a PLC. Then the second part is the model which you are utilizing, whether you want AC powered PLC or a DC powered PLC. We have AC powered PLC which can operate from 100 to 240 volt AC. You have a DC powered PLC which can work in 24 volt DC. Then you need to select the type of PLCs which you are using. Now when I talk about compact and modular, compact model is basically micro PLC in which everything is inbuilt. We will have inbuilt inputs, inbuilt outputs, then you have logic controller, that is CPU, the power supply module, everything will be in a single unit. We call it as a base unit. So that is a compact type. If you talk about modular type, everything will be separate. So in that case, you may have a separate power supply module, separate input module, separate output module, separate CPU. So everything is separate in that. So which model you want, you can decide. Let's say you have a requirement like you have a project in which you may have to use so many inputs. Let's say I need to use 1000 input in that. Input outputs, I need 1000. In that case, you cannot go with the compact size PLC. Why I am telling you this? Because in compact PLC, if you talk about Omron, we have a maximum of 320 IOs only possible. So if you have more than 320 IOs input outputs, then you have to go with the modular type. So you need to select that. Next thing is the selection of expansion card based on higher requirement. As I told you, compact, you have a limited expansion modules available for that. If you talk about the modular system, if you talk about Omron modular system based PLC, we have a provision to connect a single CPU. So similarly, some other make may have more than that, some of the makes may have less than that. So you have to do the selection of expansion cards. Now talking about, this is one example where you can see on the left hand side, you can see the first model is a 24 volt based system. So you can see the base module here. In the base module, you have 24 digital input and 16 digital output. This is possible here. Then second system, you can find one. In the second system, you can find one base unit plus one expansion module. In the third one, on the right hand side, you can find one base unit plus 3 expansion. So first model, you can see digital input is 24 and digital output is 6. So that can be output. That is not possible with this particular PLC because it is maximum is 24 input plus 16 output. So if I want again 16 more outputs on the digital outputs, you may have to put one expansion unit. Then the third one, if you talk about 32 digital input, 16 digital output, but I need 4 analog input and 2 analog output. So I need furthermore modules or expansion modules. So based on your requirement, you can select the base input. Let's say some cases you need only limited number of IOs. In that case, you may select only the base unit. But in future requirement, let's say you have a future requirement where you may need more IOs, or in a project it expands like it reaches 320 maximum, it can go more than that, then in that case you always go with the modular system. Why I am telling you the modular system is more flexible compared to your compact system. Compact system has its own limitations and it is a cost-effective system. But if you select modular, we have the compatibility and the flexibility to connect even to third-party devices also. Let's say Omron is one make. If I want to communicate with Siemens make or some other make, that is possible with the help of modular system. So that also you need to consider. Then the next one is the memory size plus expansion card. So memory size is basically the memory size of your PLC and the expansion card. If you talk about the very basic PLC, I will say the memory size or the programming steps which you can write is 2000 steps. So when you are going to develop a ladder logic, 2000 steps you can write in our Micro PLC, very basic PLC. So if you keep on increasing it, it will increase it. Let's say it will again increase 32K words. Now after that will go on. Now MB sizes are also coming, 1.5 MB, 5 MB. So these are the different memory sizes which we have. So data is basically the area where you're going to store the data, and program is the area where you're going to develop the ladder logic. So different programming languages are also available. Ladder logic is one of them. So if you're going to develop a ladder logic, that will come on your program area, that is program memory. So in this example, you can see this particular model has a program of 8K, that is 8000 steps can be written in this ladder logic, and data is 8K. That 8K, it's 8K words. Okay, one word is basically 2 bytes of data, so it is 2 bytes. So 8K means 8000 words. So into 2, that much bytes of data can be used in this. So earlier system PLC were using PLC memory cassette, but the disadvantage being the memory size is very less compared to the new system. If you see now, earlier it was memory cassette, then flash card memory came. Now if you see the latest controllers, we are using SD card now. So you have the provision to like 16 GB, 32 GB can be utilized in the modern controllers. To the next part is the scan time of the execution speed. You would have heard about the PLC scan time. So what exactly is the PLC scan time? Okay, so PLC scan time is nothing but the basic thing is the time it takes to scan all the inputs connected to the system, then the time it takes for the program to execute complete, then the output part. If you take all these three basic things like input scan, the program scan and the output scan, we call it as a scan time or cycle time. But the thing is, there is one more system. If you are using a standalone system, you can use this only these three: input scan, then the logic scan, the output scan. But if you are considering a system wherein you are communicating anything over any communication protocols, what happens in that case? Let's say if some remote IOs are connected in the system. From remote IOs, you will get the request to take the data, or you want to publish some data to other devices. So that also will affect your scan time. So that we call it as peripheral devices. So we have input scan, logic scan, then you have output scan. In between you have peripheral devices also. So that also will be involved in your scan time. So based on this, we cannot give a particular scan time now. We cannot say particular scan time. Let's say some PLC will say like we have a provision of 4 nanosecond. But as you write the logic, the scan time may increase or scan time may vary. You cannot fix scan time on any PLC. If you take any make, you cannot have a fixed scan time on that. The scan time will vary according to the logic which you are writing. Let's say if you are writing only the ladder, contact and coils, the scan time may come down. But if you are using some instructions, or if you are using some floating point instructions, then the scan time may go high. So we don't have a fixed scan time for anything. Some PLCs we have microseconds, some PLCs milliseconds, and nowadays the modern controllers, it is working in nanoseconds. So you can see this one example they have given: process overhead processing time 0.4 millisecond. So 0.4 millisecond we are mentioning, and instruction execution times we are saying like it is 1.19 microsecond. So this 1.19 microsecond is nothing. If you are using one contact or two contact plus a coil, then you call it as 1.19 microsecond. But if you keep on writing the logic, let's say you have written the logic for 100 lines or 200 lines or 1000 lines, your scan time will increase accordingly. So this is just example of our CP1E and CP1L, that is Micro Plc. So in Micro Plc, so what are the scan time given in your data sheet? But in actual, when we are doing the hands-on practice, I will show you the scan time which is coming. Then you will get a better idea on that. Next is the communication requirement for programming HMI or Modbus. So in communication requirement, let's say earlier system, what we were using is RS-232 system. Okay, so that is a communication requirement. But the thing is, the speed was very less compared to the new system, and the communication length or the program cable length was limited to only 15 meters. Then came RS-485. And in RS-232, there is one more limitation, like you can connect only peer-to-peer connection or only point-to-point connection. A single device can be connected over RS-232. But if you go to RS-485, you can connect multiple devices. We can connect up to 32 devices in RS-485 Modbus communication. Then came Ethernet, that is a basic Ethernet socket communication. After that, nowadays we are using Ethernet IP. So Ethernet IP, the speed is 100 Mbps now. The earlier speed was in kbps, now it is in 100 Mbps. So you can see the difference in the speed also. So communication requirement will vary according to your application. Let's say some areas you may require HMI to be connected with a PLC. In that case, you may utilize that. So for programming HMI Modbus, then you will use different communication methods. Then there's high-speed inputs, outputs. That is, high-speed input, if you are talking about, high-speed input is basically the encoder part. So encoder part is where you're going to use the, let's say I want to take the feedback of particular conveyor. Let's say if it reaches 5 meters, I need to stop, or I need to give some feedback to the system. That can be done with the help of high-speed input. That is high-speed counter input, we call it. So that is basically used in encoders, rotary encoders. Then talking about high-speed output, that is PTO. We call it as pulse train output. So there are servo drives which work on pulse train output or pulse train system-based system, wherein you are sending the pulses continuously from the PLC output. So this is given to the fed to the servo drive, which in turn operate the servo motor. Then analog handling capacity. So if you are using a PLC, you need to check whether there is a requirement of analog input or analog output, or if its only requirement is discrete inputs. If you are using analog input, the total number of digital input which you can use can come down based on the model. So that also you need to keep in picture. Then next thing is RTC, that is real-time clock. If you want to have any clock-based applications or anything, you may require real-time clock. Then built-in Ethernet port is required or not, optional LCD, built-in analog. So many options are given for a PLC. Let's say in our micro series PLC, we normally give option slot. Option slot basically used, let's say when you're getting the PLC, it will look at the dummy cover. Okay, so I'll show you the PLC. In that PLC, I'll explain. So we'll have a dummy cover. In that dummy cover, so you need to check which system you want to connect it with. Let's say tomorrow you have a requirement, you want to connect an HMI. So I will simply put one option card for RS-232 and I can communicate with the HMI. Let's say after a few months you have a requirement like you want to connect multiple devices on RS-485 Modbus. That can also be done because when you're using option slot, you have the provision to reprogram it. Okay. So right now I've connected to an HMI. Later I want to transfer it to Modbus communication. That also can be done. So you need to check different options available for a PLC. The last one but not the least is the programming software and network options. So why I'm talking about this programming software and network option is you have seen so many PLCs, so many make. Okay, everyone have their own programming software. Okay. So nowadays, what everyone is focusing on giving a single software for everything. Right now, if you talk about Omron, we have only 2 programming softwares available for all the PLCs which are there in existence now. So one is known as the CX Programmer, other one is SysMax Studio. So I'll explain more about the CX Programmer in the coming session, which will be today afternoon session. So wherein I will explain more into this programming software part with basic programming. So I will explain how to do the programming in a PLC. So I will explain more into the programming part in that. And the networking options is basically how many types of networks will be available or you need in a particular PLC. That also should be selected when you're selecting a Right PLC. Now, all PLC manufacturers, everyone will have their own portfolio or their own list of products. Okay, so system requirement for our PLC or our software is we need a Windows-based system. So right now we have earlier we used to have programming software which is compatible for a Windows XP. Then we have made compatible for Windows 7. Now it is compatible with Windows 10 also. So if you use PC-based system wherein you are using Windows 7, Windows 10, everything will work with our programming software. So that is a basic requirement, nothing more than that. Enough RAM space should be required if you are using multiple programs. Let's say minimum is 4 GB RAM, but if you are a good programmer, if you have multiple programs installed in a system, you may require 8 GB RAM minimum, okay, for smooth functioning of the software. If you are using multiple software, let's say you are using software of Omron and you are using software of Siemens, then there are chances that speed may go down for particular software. It's always better to give application guys and the application engineers system which is having minimum 8 GB RAM, and if it's better if you are having 16 GB RAM also. So that is the basic requirement, nothing specific more than that. If you are having a good speed laptop, you can utilize the software. Now, I was talking about the Omron PLC. Now, let us come to the Omron product specifically. Earlier, we were discussing only about the general things, what are the PLC. So, let's review what all things we have seen just now. We have seen the introduction of PLC. Then we have seen the PLC components which I use there. Then I have shown few examples, application areas, where then the selection of a Right PLC. Now let us go to the PLC specifically from Omron. So introduction to Micro PLC. This Micro PLC is nothing but a compact series PLC. So earlier while selecting the PLC, I have introduced 2 controllers there. One was compact series and the other one was modular series. So when you are talking about this Micro series PLC, so going to the Micro series PLC, that is compact series PLC, let's see the entire lineup which is available from Omron. Just like all other manufacturers, all other PLC manufacturers, Omron also have different ranges. First one we call it as a Micro series PLC, that is a compact series PLC. Second one we call it as a medium series PLC, and the third one we call it as large size PLC, or that is rack size PLC. First one is compact size, second one is medium or modular type, third one is large size or rack size PLC. So I will explain the main differences what we have. In Micro series PLC, as I said, everything is inbuilt to one controller. Let's say if you see the model itself, you can find the input channels available, output channels available, and there are few communication ports also available in that. So in this particular model, you have everything inbuilt. Input is inbuilt, output is inbuilt. Then you have a PLC CPU. Then we have the provision to connect power supply. You have the programming port, communication port. Everything is inbuilt in a single unit. This we call it as a Micro PLC or compact PLC. And the main thing is the maximum input output possible for a compact PLC from Omron as of now is 320 IOs. If you have a requirement like more than 320, you cannot utilize the compact PLC. Now coming to the second one, medium range PLC. In medium range PLC, it is a modular type, okay, and everything is separate. If you talk about the power supply unit is separate. If you talk about the CPU type, CPU is different. input output, everything is separate. So this we call it as a modular type. In this particular model, the maximum input output possible is 2560. If you see, first one is 320, second is 2560. If you see the third one, it is 5120. So large IO model. These models we normally use in process industries, wherein the requirement of input output is very large. And the advantage what we have in micro PLC and medium range PLCs, all the PLCs are DIN rail mountable. That is, you can mount all the PLCs on a DIN rail. You don't need special racks for that. You can mount everything on a DIN rail. But if you see the large size PLC, it is having a backplane. Some other makers are also having some PLCs which are having a backplane type. One example is Mitsubishi, wherein they use a backplane. In the backplane, you will plug in all the modules available. Okay, so we'll plug in the power supply module, then you plug in the CPU. So dedicated slot will be there. But if you're using medium PLC with which is a modular type, the biggest advantage being there is no fixed rack size for this particular thing. Let's say you have a requirement of only 2 modules to be connected. So you can easily connect power supply, CPU, then 2 modules, and you can close it with the help of an end cover. Rest of the spaces you can utilize in the panel. But let's say if you are using a large size PLC or a rack size PLC, which is having a backplane. So backplane slots will be different. Let's say you have 11 slot, 13 slot, those type of slot based system is available. So once you install that slot, that particular space is occupied for the PLC. So in later stages, if you want to utilize that area, that is not possible. But that is possible when you are using micro or medium range PLC. Now let's talk about the micro PLC, the complete lineup of micro PLC what we have. So I'll quickly go through this product because I need to cover more topics on this. So if you talk about micro range PLC from Omron, basically we have 3 series available, that is CP1E, CP1L and CP1H. So if you can see the slide, once the slide is loaded, so you can see we have 3 range of PLC, CP1E, CP1L and CP1H. In that, CP1 is a very basic PLC from Omron. So in this particular model, the maximum input output possible is 180, and CP1L again you have 180. If you go with the CP1H, you can have a maximum of 320. So how it is coming, I'll tell you. So CP2 3 type, where this we have E type, N type and NA type, and CP1L you have L and M type, EL and EM type, and if you talk about CP1H, we have X, Y and XA. So in CP1E you can see NA, right? NA is defined as we have analog input and output in that. That is A specifies that particular thing in CP1E-NA. If you talk about CP1H-XA, in that also analog inputs are available. So based on the model number also, you can make out whether analog inputs are available in particular model or not. So CP1E we have 3 models. E is a very basic model which doesn't have communication, RS-232 communication also. If you talk about N, that is application type. If you talk about NA, again it's application type. CP1L, L and M type, that is more advanced that compared to CP1E. EL and EM, that is a new one, which wherein you can see the star mentioning like it comes with built-in Ethernet port. In this particular model, you can use Ethernet port for programming and also for communication. And the main thing is, if you see all the compact series PLC except this EL and EM model can be programmed using USB cable. So if you are using a commercially available USB cable, printer USB cable, you can utilize the same cable for programming all the PLCs available here. So we have CP1E, CP1L is more advanced compared to CP1E, and the CP1H is the most advanced one which we have in our compact series PLC. So we have X, Y and XA type. X is the application type, Y is dedicated for motion control, and XA is model which comes with analog input and output. So in CP1E NA we have 2 analog input, 1 analog output. If you see CP1H programming steps also. CP1E, the maximum programming steps, that is the ladder which you can develop, is 8,000 steps. If you talk about CP1L, the maximum steps what you have is 10,000 steps. If you talk about CP1H, the maximum is 20,000 steps. Now coming to the CP1E model number structure. So this will be explained more and detail when you're configuring the system. But let's see the model number structure what we have in Omron. So CP1E is basically the model number or the series. So CP1E, then which class, whether it's a basic model or application model. Then the second one is the total number of IOs which are available. So starting from 10 to 60, all these are available in a base unit. Then 3 and 4, right now I am not going much into the 3 and 4 one, because in 3 and 4 it is new. So we'll skip 3 and 4 as of now. Is always input, that is digital input, and 6.1 is your output type, whether it's a relay type or transistor type. In transistor we have syncing and sourcing type, so we need to select that. And the last one is the 7. Number 7 is input power supply, which is fed to the PLC, whether it's analog input or a digital input, that is AC or DC power supply. Okay, so is my voice audible? Someone is it okay now? Okay, I'll take it forward. So this is the part number. So when you're talking about the model structure, it will be CP1E-N30DRA. So CP1E, N is means the class, that is application type. 30 means 30 input output. Then D is always your DC input. RA means relay type output with analog power supply, that is power supply which is fed to the PLC will be analog or AC power supply. Okay, not analog, AC power supply. So last digit hyphen, last one is number 7 is basically the input power which is fed to the PLC, whether it's a AC or DC power supply. So if you see this particular model number, this is applicable for L and S. Okay, so when you are talking about CP1E, the same model number structure is applicable for L and H. So you can see that in the coming slides. So I'll quickly go through this few slides which are there. So these are some of the features available in a CP1E model. So maximum IOs available. So you have E is 180 IOs, N type it is 180. Again, coming to NA, it is 140. So the main difference is in the second line, if you see the CPU base IOs, you can see in rest of the models you have the provision like 40 and 60, but in NA type you have only one single model which is having only 20 IOs. So 20 plus 3 expansions. So third line you can see how many expansion modules can be connected, that is 3. So if you connect 3 expansion modules, in the 3 expansion module the maximum IO possible is 40. Okay, so when you connect 40 into 3, that is 3 expansion modules into 40 IOs. So 40 into 3 is basically 120 plus 20 140. So that is how we are getting this total maximum IOs possible in this. And number 4 is basically the program or memory and data memory. You can find 2000 steps, 8000, 2K words, 8K words. High speed counters, 6 high speed counters are available with the 10 kilohertz and 100 kilohertz speed. Pulse train output available, not available in CP1E-E. As I said, CP1E-E is used basically in a standalone system, not a system wherein you want to utilize RS-232 or any other network. You cannot utilize this. If it's a standalone system, in the machine itself PLC is available, then you can go out with CP1E high system. So no pulse train, no built-in RS-232, no RTC, nothing is there in CP1E-E. But if you talk about N and NA, you have the provision for everything. RS-232 is available, that is serial communication. Real-time clock is available. Option boards selection is available. And option board you connect only in that module which is having greater than 30 IOs. So if you see 10, 14 and 20, you cannot use option board in that. You have to use greater than that 30. So if you have 30, 40 and 60 IOs, then you can utilize the option board and option slot. And battery is used when you want to store data in your data memory. If it's not used, the data will be lost. Not the program I'm talking about, the data which you want to store. Now coming to the architectural overview. So if you see the architectural overview, what are the things you can do in a PLC? So you have a PLC, okay? In the PLC, what are the things you can connect? Let's say I want to connect my laptop to PLC. So how I am going to do the programming? So you can use a USB port for programming. Now I want to utilize RS-232 to connect a HMI. That is possible with the help of inbuilt RS-232 port, or if you are using option slot, that is also possible. Let's say I have a base unit, I have 60 IOs. Further, I need 2 more expansion units. That is possible. So you can connect 2 more expansion unit. That is possible with this particular model. So either you can use digital input or you can use analog input. So you can use digital analog or temperature sensor units, wherein you can connect thermocouple or platinum resistant thermometer directly to this unit, and this will give the data to your PLC CPU. So this is the architectural overview. It's a simple overview, and if you want to retain the data, then you have to use a battery. Coming to the expansion IO module, so you can see the expansion IO right now. In expansion IO, as I said, we have the provision for digital input, you have the provision for analog input and temperature sensor, or you can use compo bus. That is one type of network, but that is nowadays we are not using compo bus. We rarely use compo bus now, because now everywhere people are preferring open based communication system, wherein Ethernet IP is very popular now. So you can see the list of IOs available, wherein in expansion modules you have a 16 input, 16 output, 8 input, 8 output, then you have 32. Then we have mixed option of 20 and 40. Before that, I want to explain to you one thing. In Omron Micro Plc, when I say 60 input output model, okay, in that 60% of the that particular thing will be input. So we have a ratio of 60:40 ratio in our Micro PLC, only in a Micro PLC, not applicable for any other model. So 60% will be your input and 40% will be allocated as an output. So when I say 60 IO based PLC system, out of that 36 will be input and 24 will be output. You need to keep that in mind, because if customer is asking for, let's say, 60 input I will need, so you cannot give only 60 IO based or base unit, because it will have only 36 input. Now coming to the CPU1L model number, so I'll quickly go through it. So model number is model number structure for CPU1L is similar to CPU1E, where we have CPU1L, E and M model. So E is basically the Ethernet enabled model, and L and M is the old system. So you can see the only difference what we find in L and M is the programming steps. We have 5,000 and 10,000 steps available for this, and again after that whatever you have is same. So total number of IOs, then digital this input, then this input, relay type or transistor type output, and last is power supply, AC or DC base. Talking about CPU1L -EL and EM model. So CPU1L -EL and EM model, as I told, it's Ethernet based system. Okay, so in Ethernet based system, what you have? So earlier micro series PLCs, no one was having Ethernet port in. If you take any manufacturer or PLC, we were not providing any Ethernet port in the older system like micro PLCs. It's a very basic system. It's a cost-effective system. So we will give a USB port for programming, and again you will give RS-232 for communication. But as nowadays requirement is for high-speed communication, everyone is asking for Ethernet port now. So all manufacturers now have Ethernet-based micro PLC or very basic PLC. So now we have CPU1L-EL and E model, which comes with built-in Ethernet port. The facility is FINS protocol can be used. FINS is proprietary protocol from Omron. It's a factory interface network-based system. Then socket function is nothing but a basic Ethernet. Okay, basic Ethernet we call it as socket-based system. And then a Modbus TCP function block, that is Modbus TCP is also applicable. So this is one communication protocol which can be utilized. Earlier Modbus were using a serial communication, that is RS-485. Now Modbus is utilizing the same port as Ethernet port. So we have Modbus TCP now. Now some of the features available are the option slots which you can find here. The option slots are basically used in the PLC. So in this particular model, 2 analog option slots can be put. This facility is not available in any other model. Okay, if you see other models, you can put only RS-232 and 485. But in this particular model, both the slots can be given as this option. That is, analog inputs can be utilized here. And there is built-in 2-channel analog input is available in this. You can see it in green color. That is built-in analog channel, 2 channel. So 0 to 10 volt is already given by default. Another good feature what you can find is on the bottom, you see on the bottom left, it is auto IP connect function. Whenever you're trying to connect any device on Ethernet, it will always ask for IP address. Okay. If you don't have the IP address, you can connect to the particular device. But in this particular PLC, you don't have to put any IP address. So it automatically detects the IP address in the network and it will connect. That is, we have the function like auto IP connect function. Last one is on the right hand side bottom, you can find it is basically the separate 10,000 steps are given for function block. If you see CP1E, that is a basic model from Omron, doesn't have functional block system in that. You have only ladder logic. But if you see CP1L and CP1H, we have given the provision to write functional blocks also. Okay, so you can write ladder logic and also you can write the logic in function block. These are some of the features which are available in CP1L-EL and EM. So we have 10,000 and 5,000. All main things are defined in red color. So 5,000 steps, 10,000 steps. Then number of expansion units is 3 units. Then maximum number of IOs possible is you have 160, 150 and all. And communication ports are available. 2 communication ports, single communication port. You can see all these features you can see in the data sheet. If you go through our website, you can see the product. Under the product, you will get the data sheet. So always refer, you are always free to refer. Our Omron website is www.omron-ap.co.in. So just go through that particular website. You can see all the products available. Just go through few products. You can download the data sheet. Then you can see the products available. Similarly, you have a CP1H model number structure where we have CP1H. Same thing applicable here also. CP1H, then X, Y or XA. XA comes with the built-in analog, 4 analog input and 2 analog output possible. But in this particular model, only 2 IO are available. That is either 20 IO based system or 40 IO based system. And the rest of the things are common. So we'll see the entire lineup available. So we have CP1H-X, Y and XA type. So these are the basic systems available. So full series, if you want to see, this is the full series available. So in CP1H-Y CPU units, the biggest advantage or the main feature what we have is pulse train output is having a speed of 1 megahertz in this. So as I said, CP1H-Y is dedicated for motion control. So in this particular model, you can connect 4 servo drives. Okay. So if you talk about the Micro PLC, all the Micro PLCs have a minimum connectivity of 2 servos. So if you take CP1E also, it can connect 2 servo drives. If you take CP1L, you can connect 2. If you have CP1H, you can connect 4 servo drives. And 2 servo drives or 2 axes have 1 megahertz speed. And the high speed counter also, we have 2 axes at 1 megahertz speed. And this is the fastest clock speed we have in our micro series PLC. And if you talk about CP1H-XA, the middle one, that is basically dedicated for analog. So you can find 4 analog input and 2 analog output readily available. The speed is comparatively less. You have 100 kilohertz, 100 kilohertz, and CP1H-X is a basic model. Now coming to the features, some of the features available. So main thing is programming steps which are available in CP1H PLC. This is having the maximum programming steps of 20,000 steps. So if you are going to develop a ladder logic, you can write 20,000 steps using this particular model. And data memory size is 32K word. So 32K word is the memory available for this. Now coming to the CP1 option boards. So we have CP1 option boards. In CP1 option boards, you can see the main option boards which are available. So in this option board, CIF01 that is used for RS-232 communication. CIF11 is used for RS-485 communication. And CIF12 is used for again RS-485 with a range of 500 meters. So we have 3 models. One is for RS-232 with a maximum distance of 15 meters. Second one is 485 with a maximum distance of 50 meters. And third one is 500 meters. So based on your requirement, you can utilize. Different communication protocols are available, whether host link, 1:1 protocol, no protocol, then CDL. So many protocols are readily available. These are some of the specification we can find in data sheet. I'll skip that particular part. So now let's talk about the new model which we have introduced very recently. So we have CP2E models now available from Omron. CP2 is now one of the most advanced controller we have in a compact PLC. So the main thing is we can do the data collection and you can do the interpolation part also. So some of the features or diverse functions what we have is we have efficient solution for a flexible production, traceability, monitoring, everything can be done. Improve connectivity to networking and serial device, reduced development, that is predefined function blocks available for this particular model. And battery free operation, you don't have to use a battery. Then the temperature ranges comparatively good compared to other models. So what are the features we have introduced? I'll explain only the main thing. So we have Ethernet ports, multiple Ethernet ports available for this. If you see compact PLC, you have already seen CP1L-L&M series, wherein you have seen CP1L-L&M series, where you have seen single Ethernet port. But right now, this particular model has 2 Ethernet ports, which is a big advancement in case of compact series PLC. So in this case, the second Ethernet port, first one can be used to collect data from some other device. Second one, you can directly connect to your laptop to do the programming, or the second port can be used as a switch. Let's say I want to connect one PLC to another PLC. So I can simply use the second port and connect it to other PLC. Now on the right hand side, what you can see is that is your PLC, which is having multiple option board. So you can, earlier we were having only provision for 2 port. Now we have an option for 3 port. That is, one single port can have 2 communications. So that is a new one which is available in a PLC. Now talking about the Ethernet connectivity. So you can see the Ethernet. I'll quickly go through these slides because I have a few more topics to cover. So just you can see the Ethernet connectivity available in our CP2E new model. Into CP2E, you have multiple Ethernet ports, as I said. So first one can be used to connect your system, and second one, if you want to give the data to some HMI or some other system, that is also applicable. So you can see the architecture now. So host and HMI connectivity. The host is nothing but your laptop. HMI is another device which you can connect. So these 2 things can be done with the help of your Ethernet connectivity. So you can have multiple connections here. Then machine to machine connectivity is also possible. So either you can connect multiple devices or you can connect multiple controllers. Coming to the open connectivity, again serial connectivity, as I told multiple option slots are available. So instead of 2 option slot, now we have given the provision for 3. So 3 different devices can be connected. Let's say if you want to connect one RS232, again one more RS232 from the same option slot you can connect. Third one is if you want to connect something in RS485, that also can be connected. So this is shown in this slide. You can see only 2 option slots are available, but 3 connections can be done. So one single option board can have 2 connections, that is 2 RS232 connection and 1 485 connection. So instead of 2 earlier, now we have the provision for 3. And all the function blocks on the right hand side, if you see, all the function blocks are readily available with us in our library. So no need to develop separate logic for that. So once the function blocks are readily available, you can just drag and drop it in your program to do the programming part. Coming to the most important part, what we have, that is linear interpolation. You guys would have heard about motion or what you call motion controllers. You would have heard about servo drives, and so many things are available. So in linear interpolation is nothing but the coordinated movement of servo axis. Let's say I want to draw a circle. Okay, linear interpolation is not possible for that. In linear interpolation, the main purpose of having a linear interpolation is for picking and placing applications. Let's say you would have seen gantry robo. Gantry robo will go movement. Multiple servo drives will be having a coordinated movement because you have to pick up the product from a particular line and you have to place it. So XY axis will be involved in that. So in that you will be using that. Linear interpolation is basically coordinated movement of multiple servo drives. So if you have 4 servo drives, you can have linear interpolation using all the 4 drives. And another thing is circular interpolation, which is not available in this model, but available in our other advanced controllers, wherein you can even draw the circles also. If you want to do a circle, like plasma cutting machine or some other, in that you want to draw a circle, that is possible with the help of circular interpolation. Okay. Then we have inbuilt few functional blocks readily available for packaging industry. Then these are some of the features which are available. That is temperature ranges from -20 to 60 degrees centigrade. Battery free operations, that is LED indicators are readily available on the terminal itself. And you have automatic recovery facility available in a controller. Okay. Now, if you see, these are some of the features available in CP2E. Coming to CP2E product lineup. Coming to CP2E product lineup, we have CP2E-N, that is network-based controller, CP2E-S, that is a standard controller, and CP2E model. Just like you have seen in CP1E, this is advanced version of CP1E, that is CP2E, second generation of micro series, CP1E series. So CP2E, we have network-based, wherein you have multiple Ethernet ports. Standard model, where you don't have Ethernet port, and you have last one, that is a very essential model, wherein you don't have the provision for Ethernet, but we have some features available from our other models. So you can see all the three. So first one is CP2E-N network type, second one is a standard one, and the third one is your essential model, that is CP2E-E model. Now, the main difference in option boards, you can see this is in one slide. I'll explain everything. So on the left hand side, what you see, that is the option board for old system, and on the right hand side you have new system. So on the old system, you can see we have multiple option board for communication and also for analog. On the right hand side, you can see this is the new one. So left side you can see the old one, CIF 11, 12 and CIF 01, 11 and 12. On the right hand side you can see two option boards in which you can have multiple connections. So two RS232C is available in one port, one RS232C and one 485 is available in second one, and third one you have multiple RS485. This was not available in our old model, but this is introduced now. And these are expansion modules, just like you have seen in CP1E series. Similarly, you have provision for digital input, then analog input, and also temperature sensing. Now coming to the PLC power supply part, as I said, we have AC power supply and DC power supply models available with us. So we have 100 to 240 volt AC, which can be connected to a PLC, and we have the provision for 124 volt DC also. So either you can use commercially available AC supply, or you can go with the DC power supply. Then comes the input wiring. In input wiring, you can either go with a 2-wire contact, or you can have a 3-wire contact. So either you can have a syncing type where the common is different, that is positive common, and sourcing we have negative common. Only the common will differ, and the terminal accordingly the power may vary. If you are using a positive common, it will be 0 volt, and if you are using a negative common, on the terminal you will get 24 volt DC. Similarly, you have output wiring also, where you have relay and transistor type output. In relay, the polarity, it doesn't matter where you are going to connect. Let's say you are going to connect the load to positive or negative, it doesn't matter the relay type. But if you are using transistor type, you have to always consider the NPN and PNP possibility. That is, NPN we have positive common, PNP you have negative common. So this should always match with the sensor you are using in the field. Always keep that in mind. And accordingly a model number change. And another important thing which you need to keep in mind is, whenever you are using any high-speed applications or servo based system, always keep in mind you should use a transistor type, because the output which you are sending, that is PTO output, it should have a high speed switching. If you are using a relay, you will not get that much speed. So always consider, whenever you are using a servo based system wherein you need high speed switching, always go with the transistor type output. Coming to the memory areas and addressing part, as you see, so many manufacturers are there in India and across the globe now. So people may have different memory areas. So our memory matrix is nothing but we have word dot the bit concept. So memory matrix is a diagram showing PLC's internal memory area. So our system composed of words and bits, that is binary. Bits we call it as binary. So word or channel, and always a channel for Omron is 16 bits. Okay. So one channel is 16-bit information. So 2 bytes of data. Then the concept of address is word dot bit. So whenever you're using 0.0, on the left hand side, what you see, that is a word or channel. On the right hand side, that is your bit, that is 0 to 15, that total 16 bits. So either you have a 0 channel, 1 channel, 2 channel, depends upon that. Example you can find at the bottom, 0.000, that is 0 channel, bit number 0. So when you're doing the program, I'll explain more into that. So these are the different memory areas available in our PLC. So basically, as I told, input interface, output interface are there, and inside you have PLC CPU. Similarly, you have input bits, that is CIO areas. We call it as common input output areas. Then we have CIO output, that is output areas. And one thing to keep in mind is in Omron Micro CLC, that is compact base PLC, input always starts with 0.0. So 0 is the channel, first channel which is available in the input side, and output always start with 100.0. So when I am going to connect any one output, first output, it should always start with 100.0, then 100.1, 100.2, like that it will go. Then user areas, we have different areas available like work area. So work area is nothing but a memory bit. Holding area is the area where you can have a last bits. That is, even if power goes off, the holding area will bit the take the status as such. Then we have data memory area, DM areas, timers and counters. And on the right hand side, what you see is system areas. System area is nothing but related to the PLC. That is not edit much on these areas. So it is auxiliary, that is system area, then conditional flags and clock pulses are available. Then IO allocations, you can see in compact PLC we have options like different channels to be utilized. And in Micro PLC, Omron Micro PLC, always keep in mind, in one single channel in your input, you can use only 12 bits. Okay, rest of the 4 bits are reserved, which cannot be used. So when I say 0 channel, it will always start with 0.0, 0.1. It will go up to 0.11. It will not go more than that, because 12 to 15 you cannot use in Micro PLC. But this is only restricted in Micro PLC, not applicable for medium or large IOs or the advanced controller. In that, multiple areas can be utilized. Similarly, in output, you can utilize only 8 bits. That is, one channel means 8. So if we talk about CIO 100, that is 100.0, 100.1, it will go up to 100.7. Then the next channel will start 101.0. So 101.0 is the next channel. So if you want to use 100.8, 100.10, that is not possible. So this is one point to be kept in mind when you're selecting Micro PLC in Omron. So channel, input channel always takes only 12 bits, output channel always takes 8 bits. Some of the memory areas available. Common input output area is where your physical inputs are connected. Data memory area is basically to store the data. And if you want to have any word memory or word area, data memories can be utilized. And this is retentive memory. Even if power goes off, the value which is stored in D memory will be always there. You don't have to worry. So this is data memory. Then EM memory is similar to data memory. It is additional memory which is used just like a data memory. Then we have work area. Work area is nothing but the memory bit which you use. Some other make may have some other name. So if you take Mitsubishi, it is M bit. If you take Omron, it is W bit. So we call it as work area. So this work area, you can use it for so many purposes. It can be used only in the program. So this particular area cannot be used to transfer the data with external IO terminals. That is, if you want to transfer the data to IOs directly using W, it is not possible. Then we have holding areas, then timers and counters. So if you take any model, the total number of timers and counters will be same. If you have a particular model with 256 timers, 256 counters will also be available in that particular model. If you have 1024 timers, it will be 1024. So we have holding area. Holding area is basically a retentive memory. So retentive area where you are going to use that particular area. Even if power goes off, the bit status will remain the same. So you don't have power goes off and the particular switch is going off. You don't have to worry about it. Arrays, as I told, auxiliary array is basically used in IO systems, okay, or a system memory. It's basically a system memory. So auxiliary having one base unit, but I want it. So you will be confused how I am going to write the next connected module. So you don't have to worry. If you are using a single channel for your base unit, the immediate next channel can be used for your expansion. Okay. So in the example, you can see 0 channel is used for input CIO 0. If you're connecting an expansion unit, immediately the next channel can be utilized. That is 1.0, it will start to 1.11. Similarly, in output, if you have single channel in the base unit 100, 100.0 to 100. The next channel will start from 101.0 to 101.7. So directly you can use the next channel, next available channel. Let's say in the base unit I have used 2 channels as an input. So 0 and 1 I have used. So you can use the third channel, that is 2.0 and 1 used, then 2.0 to 2.11 can be used in your expansion. Okay. Now these are some of the very few things which I have explained about PLC. So if you talk about PLC, it's a very big topic to be explained. Okay. In this particular session, I am able to cover only very basic things about PLC. Maybe in the coming future, we'll be having more sessions where we can impart more knowledge on the PLC part, how the advanced controllers work, everything we can do. But right now, I have the provision to show only very few things because of limited time. Okay. So in the coming sessions, you may expect more from Omron. So now coming to the ladder diagram logic. So now we have seen the product, some of the features of the product. Now coming to the programming. So what are the programming softwares available? Okay. Before that, I need to tell you that we have 5 different programs for all the PLCs. One is your instruction list, another one is structure test. Main thing is your ladder, that is the third one. 4 is the function block programming, and the 5th one is sequential function chart or flow chart, we call it. So all these 5 are in your IEC 611-3-611-3. So that is the standard for your programming language. So in that, all the 5 programming languages are available, and ladder is the most commonly used by all the manufacturers now. Ladder logic, instruction list, structure test, everything available in now. We have functional blocks also. Manufacturers who are more focused on programming, let's say if you talk about Siemens or Bradley, they are more and we have the option to do in functional block. All the basic PLC. Then we have logic and function block. Okay. So ladder diagram been established as a standard for which is comparison between the hardwired and PLC ladder. Earlier, conventional, as you would have seen in the initial slides, how using the relay logic. That was a hardwired part. That is same logic you have used in PLC ladder also. PLC ladder, if you see, it is similar to ladder. That is the relay logic. Sometimes we call it as relay logic only. So it will be having contacts. It will be having coils, which are the components of a relay. So similarly, the PLC is derived from that only. Ladder logic is derived from that only. I'll explain few of the components in ladder diagrams. In the second half session, I'll be explaining more into the programming part. But right now, I'll just give you an overview of the product, some of the components available. So we have ladder diagrams, we have contact, NO and NC contact. You guys will have no under NC contact. NO is normally open contact and NC is normally close contact. Once it operates, NO becomes NC and NC becomes NO. That is, close will become open and open will become close. So this is contact. Then we have a coil. Coil is normally used in the output side of the ladder. Whenever you are using, there are some criteria for writing the ladder logic. So on the input side, always you should go with the contact, and you on the output side you do always go with the coil part. Okay. Then we have instructions. There are certain instructions which you can use to perform higher order functions. Let's say if you want to move from one data from one place to another, you can use the move instructions. Or if you want to use, let's say, arithmetic operations, I want to add two datas. So add operation is there, subtract operation is there. So many higher order functions can be used with the help of instructions. Then there are certain general ladder rules. The program can be executed from the first address to end. Criteria will be like it should be starting from left to right, from top to bottom. So many things are there. You cannot use coil in the starting of ladder. So there are certain criteria which you can see when you are doing the programming part. Talking about the programming device, we have programming device earlier when old PLCs were there, as explained earlier also. All the programming devices, we had a programming console earlier. Now we have programming software where you can use your laptop or desktop to do the programming. So programming devices, you use a programming device to enter and monitor the program. Like if you want to write some logic, or if you want to monitor, or if you want to see the running PLC program, that also can be done with the help of programming device or the programming software. So we have two programming softwares are available right now. CX Programmer is one, and other programming software from Omron is Sysmax Studio. So CX Programmer is widely used for programming and monitoring of PLCs. This is mainly used for programming ladder logic and functional block diagram. Okay, and another is CX1. It's a package of softwares. 9 or 10 softwares are available in that package. In that, CX Programmer is one. So this can also be utilized. Now, if we talk about Omron, we have different training programs available with us, and I'll just give you a glimpse of the training demo kits which we are using for this purpose. So this is almost end of my presentation. So I'll just show you the training kits available with us. After that, I will just take the Q&A session. You can ask the questions, and I'll take on that. So just have a glimpse of training kits available from Omron. So on the left hand side, you can see we have the control panel with the PLC setup available with us. We have 3 sets available with us, and we have on the right hand side, what you see, this is the conveyor setup, where the bottom one, what you see, that is a small setup of a conveyor. The line which you see, the green, dark green color, that is basically a conveyor. And you can see different sensors available. You can have a rejection system. I'm not sure whether the image is clear or not, but this particular model you can see. And on the top, we have operation panel where you can see the selection buttons, the push buttons. So if there's any training requirement, or if anyone is training part, we can help with that also. Now, related to any questions, you can ask them. I already have a few questions forwarded, so let me check on that. There are some of the questions available, so I'll take a few slides for microprocessor. This PLC is better because of its rugged nature. Thing is, we have a very rugged compartment for PLC with heatsink facility available, not like the microprocessors what we use normally. And microprocessors and microcontrollers are such devices which you cannot use in industrial environment. Okay, so always it's better to go with the PLC, which is having better rugged feature compared to microprocessor. So what is the sensor there to check whether the bottle has been filled? These are some of the questions which I have received. So what sensors are there to check whether the bottle has been filled or not? We have different kind of sensors available. We have photovoltaic sensors also for that to check the content of the bottle, or you can use a vision system also for that. So either of the two you can utilize. Then where we can use relay type PLCs or transistor type PLC, as I said, relay can be used in any areas where you want to switch very large load. There you can use the relay type. And if you want to use a transistor type, as I said, if you have any areas where you need high speed switching, or if you want to run a servo drive precision, then you can go with transistor type. So PLC come under industry 3.0, but what can be done to make it 4.0? 4.0, now the advanced controllers what we have all are following this industry 4.0, but we cannot say everything PLC related to 4.0. 4.0 is basically the network or the systems which you are using along with the PLC. If you see our advanced controller, as I said, we have the provision to transfer directly data to you DB also. Similarly, you can take the data, all the datas. In the morning session, Mr. Rishikesh was talking about the IIoT. The IIoT is basically Industry 4.0. Okay, so Industry 4.0 is one part which comes under IoT, Internet of Things. So what basically it does is it is having the facility to collect data from the entire line, even from very small size. What is the provision? So if you have advanced controller which can have Intel processors, those controllers have a main part in your Industry 4.0. So what is actual PLC peripheral is nothing. As I said, when you talk about scan, about input scan, logic scan, and then you have output scan. But what about the peripheral device? The device is nothing but the remote connected over network. Let's say I have Ethernet connectivity. You have devices connected in Ethernet. So all those devices which are there considered as a peripheral device. System requirement, as I said, you can use RAM requirement for GB. It is better to have 8 or 16 GB if you are having multiple softwares. How come PLC is having a better? How the PLC is manufactured? The casing part, let's say the PLC doesn't allow any humidity to go inside the PLC, and it is having a better heatsink. As I said, Omron also started manufacturing PLCs or advanced controller, which comes with micro. So now we have advanced so much that we are using microprocessors now. Where it's a challenge, it's always go with the PLC. Any PLC which is costing less than 8,000 value on that, but it's always good to go with the compact series PLC, which will be cost effective and which PLC students can utilize in your systems or your projects. You can always go with the micro series PLC, which are cost effective compared to your old systems. So hope I have answered some of your questions. My apologies if I'm not able to questions, and we'll get you back on that. So I would like to thank each and every one of you for spending your time, taking a valuable time to attend this session. So that is all from your side. And this is your topic on basics of PLC. Today's second half session, I will be taking a PLC programming part, where I software, and we will do a little hands-on session. So I think the afternoon session, I request everyone to participate in the same. It will be a better session. It will be more on to the hands-on part, how the PLC settings are done, how you can do the programming, the basics of programming. I'll tell you. So hope to see you in the second half session. So now I'll hand it over to VCET team, so they can take it. That's all, ma'am, from my side. Okay, thank you.
Hello everyone, I am Professor Sandeep Pawar, who would like to Hello everyone, I am Professor Sandeep Pawar, who would like to give vote of thanks to today's speaker, Mr. Soju Sasindran, for giving us a presentation on Introduction to PLC. The session was wonderful and very knowledgeable. The content he delivered were basic PLC components, advantage of PLC over conventional panel, application areas of PLC with example, introduction to Micro Series PLC, architecture overview of PLC, feature and specification of Micro Plc. Similarly, the session was wonderful and very useful. I also like to thank our management for providing us this opportunity and permitting the Automatus 2020. Also thanks to our principal Dr. Harish Vankundre sir for continuous support and guidance. I am also grateful to HOD of Hello everyone, I am Professor Sandeep Pawar, who would like to give vote of thanks to today's speaker, Mr. Soju Sasindran, for giving us a presentation on Introduction to PLC. The session was wonderful. Content he delivered were basic PLC components, advantage of PLC over conventional panel, application areas of PLC with example, introduction to Micro Series PLC, architecture overview of PLC, feature and specification of Micro Plc. Similarly, the session was wonderful and very useful. I also like to thank our management for providing us this opportunity and permitting the Automatus 2020. Also thanks to our principal Dr. Harish Vankundre sir for continuous support and guidance. I am also grateful to HOD of Instrumentation Dr. Deepak Gowli sir and conveyor for Automatus 2020 for continuous guidance and support. Thanks to all coordinator and organizing team for hard work and effort. Special thanks to all participants to make this event a great successful. Thank you.